Hello, everyone. Welcome to Cassandra Developer Workshop Europe, especially for the European people who are in the Central European summertime friendly time zone. I'm Alex Voloshev, and that's Cedric Lunden. Hi, Cedric.
Hi, how are you guys? Very happy to be there. I think this is the second time we are doing a dedicated event from EMEA, right?
Yeah, we did events for the United States, we did events in India Standard Time, but now it's finally time to get to Europe.
Very nice. Okay, so as usual, today this is not only me and Alex, we also have a full crew of people behind us answering questions either on YouTube, Twitch is a backup, or mostly Discord. Please use Discord for your questions. Today we will do quiz, hands-on, but you don't have to install anything.
Yep, we prepared everything for you.
Yes. So this is the agenda for today. Housekeeping, Apache Cassandra, why, what, and when, data modeling with Apache Cassandra, advanced data type, lightweight transaction and batches, and in the end, we will share you all the resources we have, the slide, the exercise, and we will use an instance of Cassandra online, so you can use this forever. It's a free tier. So let's see how it goes. So this is the setup for today. You can see we are streaming on two platforms, YouTube and Twitch. YouTube is a main. We do have moderator watching for your comment and question on the top chat, but we also have a Twitch backup stream, but not that many people follow the question there. So please keep with us on YouTube. If you do have question, please go to Discord. We do have a dedicated room. People are sharing the link of the Discord room at the moment on every platform. I told you everything will be available on GitHub. We will share the URL in a minute. And all the exercise, everything will be done on DataStax, Astra, Cassandra as a service in the cloud, and on the free tier. Everything will be free and you don't have to install anything. So there is 4 screens, 4 parts. So at glance, it might be overwhelming. And so just to show you, this is how I set up my own laptop to follow one of our workshop. I keep YouTube on the top left-hand corner. I do have my Astra instance. I do have Discord for question, reading, question and answer. And I do have my files, the files that we will download from GitHub in the very beginning. Here, there, ready to go. We will also do questions, quiz, enjoying quiz. But for that, I use my phone. So to illustrate about the question, please go to menti.com. You can go to the website menti.com, or you can use your own mobile phone going to the website, or you can also download the Mentimeter app. Once you're on the page, please enter the code 640466, and it will show you something like that. So the code is 640466. So I think people are sharing the code on YouTube chat as well. The code is written on the top of my screen. Okay, go to menti.com, use the code 640466. And so for now, it's not a quiz, simply question, let's chill out a little bit. Simply some questions just for us to adapt our explanation to your level. This event is meant to be live and interactive. So please be with us. When you are on the screen, you can click on the thumb up on the bottom right-hand corner, just to tell me, I'm ready to answer your question. And I can see that I already have 80, 90 people, or almost 100 now. So keep going there. For your information, we had 2,000 registrations. So I expect to have at least 300 people on Menti with us today. So let's wait a little bit for people to join. This is the first question. I will go back to slide, do some exercise, and go back to this Mentimeter later. So when we are done with the question, please keep this tab or your app open, because we will go back again and again to this form, and I will never change the code. So 230 people ready to answer our 4 first questions. So I will wait until 250 and I will start. So for now, as I told you, it's not a challenge, not a quiz, nothing to win yet. But in a few minutes, we will have a quiz where you can win some swag, t-shirts, mugs, socks, stickers, full package for you.
Yep. Easiest way to join us is just to launch a browser at your mobile phone and go to menti.com using code 640466. It's on the screen right now. I'm ready to vote, and you?
I'm, mostly driving the form.
Yeah.
I won't vote for this one. But if I see you on the top answer for quiz, I know that you are there. Okay. Oh, we will really reach these 300 guys ready to connect. So again, very happy to have you. If you join us right now, we are doing some Mentimeter quiz just to start. And boom, we cross the 300 mark. Nice. So a few questions in the beginning. It's always like that in the beginning. We need to wait a bit for people to join, not to get people frustrated. Okay, so I think that the thumb up is slowing down. So I will start with question 1, and you can still catch up if you missed the first questions. Okay, first questions is, how much experience do you have with Apache Cassandra? Okay, not at all. This is totally expected. Today level is really beginner, getting started with Cassandra. You might have read in the email, in the invite, that you can have a free voucher to pass the certification, the Cassandra certification. And this is true. We will share you the link in Discord or every platform again. This 3-hour workshop is not enough to pretend passing the certification, but it will give you the first main concept to understand what you can do with this NoSQL database.
Yes, really a lot of people spend many years making Apache Cassandra great. So now it's not enough to attend a 2 or 3 hours workshop in order to get a certification exam passed. So if you want to be successful with Cassandra and if you want to achieve your certificate, really, you have to go to the academy.datastacks.com. It's absolutely free, and you should take your path. For the developer certificate, you should take a developer path, and for administrator certificate, you obviously need an administrator path. Take the courses. There are 3 free courses for each. They're absolutely free, and then we will explore our colleagues will explore with you the deeps of the Cassandra, so you will be ready to be efficient and successful and earn your certificate, really.
Yes, that's true. Okay, so that's a lot of information. We will give you the same information in the end. For now, it's just getting your level. So yeah, this is also expected. Not that many people already follow one of these workshops. I think this is number 16th, if I count well. But we did not that many for EMEA region. Each time is very late for us. I'm based in Paris. Alex, you're also based in Germany, so we should do more of these EMEA events, right?
Definitely. But anyway, people be doing great workshops not only regarding the Cassandra essentials, but also regarding like Kubernetes, distributed testing later this week on Wednesday, and so on. So if you are attending this workshop for the first time and you will like it, what you have to do is to subscribe to our channel. See you next workshop then later.
Yes, so everything is recorded on the YouTube channel. We not only are live, but we also record everything. So you can go back and watch the stream at your pace, pause to do the exercise if sometimes we are going too fast, because 3 hours, we need to speed up in some parts, to be honest. Okay, and we do have a fair distribution about with personal and business. Okay, that's legit. I like the fact that we have, almost more than 300 people there clicking on the mobile phone meetings. So I will wait until the 300 and we will start with you to download the materials and then a few slides. Okay, 300 mark. So I will go to next, but as you can see, next is just a thank you. So keep this window open. We will come back there later for a quiz. So now I'm going back to the presentation mode. And I will ask you to download everything right away on the GitHub. So github.com/datastacks-academy/Cassandra workshop online. So download everything as a zip. It's really the better way to go. It could take a few minutes because we do have a big PDF file. Those are the slides for today. So the sooner you download everything, the better. And you can see later during the exercise, we will import files called notebooks, your textbooks exercise, and we will drag and drop from files in this zip into the tool. Let's call it the tool by now. So, and second, I told you that you can have a free certification voucher. So this is the URL to go to fill your email address. I think also your Discord username, just to be sure that you really attended one of those workshops. This voucher was about $400 US dollar. So that's a good opportunity for you to take it for free. So 3 hours is really getting started. And if you like it, if you enjoy it, if you want to learn more about Cassandra, again, we will share the link to the DataStax Academy later when you could do MOOC.
Yep. Please notice what this voucher means: free examination, free exam, not the free certificate. So you still have to do your job, wear your own backpack, and earn this certificate on the exam, passing the exam.
Yeah. As we said in IT world, there is no free meal, right? So it's an opportunity to pass a certification, but hey, first you need to learn what it is, right? Okay, so I will let you download. I think link has been shared on every platform, and we can move to what is Apache Cassandra, why you should care, and when to use it. Okay, so Apache Cassandra is a NoSQL distributed database. You can install Cassandra on a single machine, what we call a node, a single node, and the capacity for a node is about 1 terabyte and about 3,000 transactions per second and per core. But it's a distributed database, and you should think about Cassandra when your data cannot fit on a single machine anymore. Not enough capacity, too much throughput, not enough bandwidth. You cannot absorb so many requests at the same time. And yeah, you should install Cassandra on multiple nodes. In those nodes, there is no masterless architecture. all those nodes are communicating with a gossiping protocol by peer-to-peer. And we can group logically those nodes with something called a data center or a ring. Okay, so with these rings, what do we do? And this is also the name of the Discord room, Fellowship of the Rings. Now you get the idea. All right, so the first capability of Cassandra is the scalability, linear scalability. So I hide the green and red bars here. What is really important is the blue, Cassandra. The more throughput you need, the more nodes you add. The more volume, the more throughput you need, the more sense it is to use Cassandra. So it's scaled linearly, and this is one of the reasons the web giants out there all using Cassandra. It has been created by Facebook, and now most biggest user are Apple.
Yep, and biggest contributor is Netflix.
Yes, and those guys, we are speaking about more than 100,000 Cassandra nodes out there. So it scales a lot.
Yep, I want to say a word about it. As an operations guy, I can set up any test, any database on any test to be fast or to be quick, because it's all magic in the config files, let's say. But this slide, Cedric, could you please switch on the last slide with Yep, this slide is not about the performance, although Cassandra is obviously very quick. This slide is about scalability. So when you need better performance or higher capacity, you just add more nodes, and we have very low to zero overhead on adding new nodes. So you add new node, you have better throughput and higher capacity. And that's how it works, and that's really great. You don't have to worry about adding new nodes. And when you add a new node, that's a cluster job to take care of the data and reshuffle data to the new node. Then you decommission a node when you don't need it anymore, like Black Friday is over, you want to decommission some node. It's cluster's job to reshuffle data back to the previous set of nodes. That's great.
Yes, you made a point, and this is why we would rather go to horizontal scaling, adding nodes when you need to, rather than vertical scaling when you power up your server with CPU, memory, or network. First of all, is costly, and it's you lack of flexibilities. So Cassandra is all about horizontal scaling. Let's move forward. So this is your ring, Cassandra ring. In there, you will put some tables. Okay, there is a schema. You define tables. What a surprise! In this table, you will set one of the columns called a partition key. Very important. When you define the table, you define the partition key. And your data are distributed based on the values of the partition keys. So what I want you to realize on this slide is, even with the very small tables, 20 records, you can see that they are distributed around the cluster, around the ring. And so if you do select star from a table, it's not a good idea, because you are doing what we call a full scan of your ring. You need to request each node to get pieces of the answer. And even with this first slide, you might state that whenever you want to request Cassandra, you should provide the partition key in the workloads, the red column. If I want to get all the cities from the country USA, boom, I will go to the node holding all the USA info and retrieving all the info in one go. I don't need to contact multiple nodes. And this is the way to go, distributed.
Yep. I want to explain why it happens exactly this way. So take a look, people. Cassandra is big data ready, and it's ready to handle any amounts of data. And imagine how usual regular relational database works. As long as your data fits to a single machine, fits to a single server, it's fine and it works pretty well. But as soon as you have really big amounts of data, then you have to start sharding. So you split your data into groups and put it to multiple servers. Anyone who did that already with MySQL or any another relational database knows how much pain into that because, well, basically those databases aren't designed to work with distributed and separated data. Cassandra works differently. Cassandra is designed to work with any amounts of data. So from the very beginning, we already start to split data natively using partitions. And then we spread those partitions over the cluster, over the ring, to have data over multiple servers. Good thing, if you have more and more data, as said before, add more nodes, and you will have still your cluster available and running efficiently, even if you have really petabytes of data like Apple has, for example. Apple is the biggest user of Cassandra. And well, but then you ask for the partition, we will see it later. You have to specify the partition ID to identify like which server you should ask. If you don't know your partition ID, therefore you can't identify a server to ask. And then Cassandra will start self-defense, like you don't know which server to ask. I don't want to do a full cluster scan. Please don't force me to do it. There is a way to do it, but basically if you have 3 servers, it's not so big deal. But if you have 3,000 servers, your query must be executed basically on every server, and then that's a big problem. So don't do cluster scan. We will explain how to do it later in this workshop.
Perfect. Thank you. Okay, so now let's think that I do have distributed my partition value around my ring. And instead of having the value of the partition key, we hash the value using a hashing function to get tokens. So what you see here are numbers, and colors are called token range. One node is in charge of a token range. The token range is per table, and it can go 2 to the power 64 to minus 2 to the power 64. It's the 64-bit numbers. And Cassandra evenly distributed this token around your nodes. Okay, so now my data is coming. I want to insert something, and the partition value, when it has been hashed, give 59. I can contact any of the nodes, but hey, this node is not in charge of 59. So this guy will become a coordinator node for the request. For each request, the node receiving the request is the coordinator node. This guy, I'm not in charge of 59, so I will simply move 59 to the guys who is in charge of it, the replica nodes. And I'm happy with that. So data is distributed. Data is also replicated. And the parameter to do that is RF, meaning replication factor. So if the replication factor is 2, now the data live, every single record live in 2 nodes. And now if I come back with my 59 and ask now this guy in blue to insert 59, this guy will send the data in both replica. And as you can see, now the coordinator node is the guy in blue. It is changed at every request. Best practice is to use an odd number. So best practice recommended is to use 3 for replication factor. Now your data, every single record lives on 3 nodes. So I come back with 59, and now I will send my 59 to 3 replica. You got it? So data is replicated. And I told you there is no master in there. Coordinator node has nothing to do with master or anything like that. It's just the guy in charge of the request. So what you can do with that? Well, that means you can lose any of the node. And this is a second range of use case for Cassandra. No data loss, 27 availability. You can lose any of the node. And this is especially useful when you are running on commodity hardware. And as I told you, Cassandra like horizontal scaling, small machine, a lot of machine. And this is one of the reasons why you can lose any of the node. So what happened? 59 now will be written in the two remaining replica. And as this guy cannot send the last pieces to the remaining node, it will hold the data on a dedicated file locally called a hint. And when this guy comes back online, then everybody will stream back what he missed. And with that, you can totally do, rolling restart, upgrade one of the node. And when you put this node back online, all the data are streamed to him. This hinted handoff mechanism is set up by default to 3 hours. You can expand the duration, but if the node is down for 24 hours, let's say, when the guy come back online, then there is potentially a huge number of data to stream to him, and it might take some time to catch up. And so we would rather, bring a totally fresh new node instead of just bringing back a node that has been down for more than the hinted handoff period.
Yep. Cassandra has a lot of defense mechanisms to protect itself from the inconsistency, which may happen if one of the nodes is not available. Hinted handoff is the first layer of self-defense. If your node was down for less than 3 hours by default, then it will be recovered fully automatically, and that's a cluster job to take care of it. If your node was down for longer than 3 hours by default, then it's easier to decommission this node and bring it back as a new one, so data will be reloaded from neighbor's node, and node will be active without possible issues with hinted handoffs being stored for too long time. That's it. One more thing to say, Cedric told it already, but I really want to highlight it because it's a very common misconception. People start to think of coordinator node as a master node, which is completely wrong. Cassandra is masterless. So we have on the screen 6 nodes, like 17, 33, 50, and so on. Every of them is absolutely ready to be the coordinator node, and every of them will do the job as a coordinator node when it gets the request. That's important. Every of them have the same duties.
Yes. Okay. Until now, I show you a single ring. But in a Cassandra clusters, you can have, and you will probably have, multiple rings. And the good part is you can install those rings in multiple locations on the planet, and you can read and write from anywhere. So let's say I'm in London, UK. I'm writing a data. The data will be replicated asynchronously under the hood everywhere. I don't have to handle it on my own. Even if the bandwidth is not that good between 2 data centers, then the data will be replicated when it can. You can enforce consistency between the ring. We will show you in a minute how to do that. But if the network is not fantastic, it's not a big deal. And it's a 2-way replication. Now, if I write a new value in SFO, California, boom, again, it will be updated everywhere. Last write win. And each time we use a timestamp to know which is the last write. So what I can do with geographic distribution, you can also do it in hybrid cloud and multi-cloud environment. You might already have think, oh, I've started to use AWS for some of my project, but Now I may have some free Microsoft Azure for 3 years plan. What with Cassandra, you can totally have the same data layer available across multiple cloud. And also, by the way, on-premise. And now if I update my customer repository on-premise, then every cloud is updated. Like that. You don't have to do it on your own. Yeah.
This platform and location agnostic, well, first of all, about the geographic distribution. It gives us two very big benefits, like very solid benefits. First one, we store data close to our customers. That's especially important for international companies. Those are, well, most of them in the 21st century. Internet is everywhere. So you have clients in Australia, you have clients in the United States, you store your data in the data center located close to them, and they get their answers in milliseconds, and that's great. So speed is the password, and that's very important to be quick on reaction and response. First point. And second point, which for me is not less important, it's not only a fault tolerance of the system, but disaster tolerance of the system. I mean, true disaster tolerance. One of our clients got a data center in New Orleans, and I bet you remember about this huge typhoon, or how it was named, the one which destroyed New Orleans some years ago. I don't remember the name now, but I bet you've heard something about it in the news. Their system was just working and fully operational because it was not the only data center they were using, and they use it simply a data replicated to another data center. So that's not just a fault tolerance, that's a true disaster tolerance. The same relates to hybrid cloud. You can have your data on AWS, let's say, and Google Compute Platform. Clouds aren't perfect. Well, no one is perfect and nothing is perfect. And cloud providers also get some troubles from time to time. And that's very fine as long as you have data centers in our clouds. Or third thing, which is very often forgotten, but not less important for a lot of the companies. GDPR restrictions, for example. As you can specify the location and data center for the data to be stored on, then you simply can say what I want the data of my German clients to be stored at the data center located in Frankfurt. And when we are following GDPRs and over local restrictions properly, so data of your German clients, store it only in Germany and not in the United States or any another place. So you can easily handle where to store data of which client or these kind of things. So specifying the location, it's really cool.
Yeah, that's a very good point. You know, this cluster is kind of multi-tenant. In there, you do have multiple logical database, which are called key spaces, like Oracle schema. And for every single key spaces, you can say, this data should remain on this ring, and maybe this data should be available everywhere. And this is how you achieve GDPR or limit location of some data in one data center or another, like Germany. You got it. Also, I see some question on Discord about what happened if the coordinator node failed, or even the full data center failed during the time when I do my request. You might say, oh, I'm screwed. I got an error message. Well, no, because at the driver level, the library that you will use in your own app, at the driver level, there is a retry mechanism. And if, for some reason, all the nodes goes down when you execute your queries, then the driver will retry. And if for some reason one ring is not available anymore, the driver will do the load balancing transparently like that. And so you can totally shut down any nodes and it will do the load balancing for you live. You don't have to set up anything.
Yep. Cedric, thank you for mentioning that because it's really important. People, take a look. Cassandra driver is a real piece of software art because it's a very smart thing. It does a lot of work hidden undercover, and most of people even don't know how cool it is and how much work it does because first of all, Driver at startup loads a lot of data into itself about the schema distribution and the cluster. So when you ask to load your data from a cluster, like select something from something, driver will not just ask some node, hey, give me this data. But as driver knows schema allocation, it will ask node exactly responsible for this data to retrieve the data from it. And it's really great. So less network operations, you get your answer faster. First thing. Second thing, it's obviously does a load balancing as you have multiple nodes due to replication factor responsible for the data. Cluster considers network conditions and knows which node reacts faster. And that's really great. So it tends to ask node which is closer to it, still doing load balancing. So asking multiple nodes, considering it. And the last point, as said by Cedric, if your connection failed and coordinator node was not available, driver will choose another node and ask a new node, again retrying the query you asked till it reaches the limit of connections, like if driver has no connection with cluster anymore when cluster is running. Last year, we did a really great demo in Developer Day Paris when we were running Cassandra cluster on multiple data centers like AWS, Google Compute platform, and one our own on premises. And we have an application running to show how Cassandra works, especially designed to be very fragile, like break in any situation, don't know what to do, throw exception, and stop working. And this application was working with the closest data center. I believe it was AWS. I don't remember exactly which one of them. Mm-hmm. And when we go to this data center and shut it down completely, like kill -9, boom, data center is down. No decommissioning, just abrupt shutdown. And this very fragile application just switched to next available data center without even noticing it. So that was a driver job to switch to a next data center. That's lovely.
Yeah. Yes, I think we do have the recording on the YouTube channel. You can go and watch it, but maybe also we should show the demo at some point. 3 hours, it's not a long time, but maybe we can make it fit some kind of this night demo. Maybe. Okay, so that's very, very important. I cannot go too quickly with this one. In a distributed database, I mean, not fitting in a single machine anymore. You hit what we call the CAP problem, the CAP theorem or McBrew theorem. You cannot achieve 3 capability at the same times. You cannot have consistency between the nodes, data availability, and partition tolerance. So partition tolerance means I lost the network between 2 nodes, between part of the nodes. And in system where you do have a master, where the portion of the network without any master need to elect a new master. And when the network comes back online, now we do have a split brain problem because you do have 2 masters in your cluster. It's not working anymore. With Cassandra, we told you data is replicated and there is no master. So by default, Cassandra is AP, availability and partition tolerance. But we will see in a minute that you can check, you can set up your request to go from this comfortable zone, AP, to more consistency. But there is a trade-off for that, and we will see that in a minute. So for now, don't worry, just be AP. Okay, so same configuration as before. I do have my 6 nodes. Client would like to write or read, working the same way, something into a node. Remember, replication factor 3, I send the value to 3 replicas. And this is here the trick. How many times do I make my client wait until I can say, okay, the request has been successfully executed? Well, this is your call to decide. This is you to decide. In the request, you will define a parameter named consistency level. And first value is 1. So you will only wait for a single node to get acknowledgement and say, okay, now the request is okay. It is the fastest. But as you can see, replica number 2 and replica number 3 won't have immediately the value. So you are not as consistent, but you are very fast.
That's important to understand what what coordinator nodes ask all the replica nodes simultaneously. So in the good network conditions, when all the nodes are operational and available and quick, you will get the same time for the response on the consistency level 1, and consistency level all we cover soon because all nodes react at the same moment. But we live in a real world with no unicorns. So usually you have some network issues, power issues, and so on and so forth. And in this case, obviously, consistency level 1 is the fastest way to get your data.
Second way is the recommended one, both for read and write, and it's called quorum. And quorum means now I would like the majority of my node to answer to be sure that my request has been successfully executed. So now the majority of the node are updated. And this is the reason why we recommended odd replication factor. Okay, there is yet another consistency level which is called whole. So now I need all my node to answer, and I'm very confident that all my nodes get the latest version. I'm fully consistent. Yeah, but you know what? Now you are not available anymore. If one of the nodes failed, you cannot ensure consistency level all. It's done. So we shift from AP to CP, consistency and partition tolerance, and less availability. So again, this is your choice. Either you want to go very fast, go the recommended way, or maximum consistency at the trade-off of availability. And
yep.
Yeah, and so just the immediate consistency, which is very important, and this is why we recommended both quorum for read and write. Let's say that I've written my data with consistency level quorum, the two nodes with the check mark. And at the very same time, there is another client requesting the same data with, again, quorum for read. Well, and with this guy, no luck, we will get answer from one check-in node and the node in the bottom that has not been checked. Okay, now the coordinator node get two different answers coming from two replica. And you know what? The last write always win. So comparing the timestamp, the coordinator node will know which one is the correct result and give it back to the client. And so with quorum, you are sure to get the latest value when you read. And so the formula to ensure this immediate consistency is to say consistency level read plus consistency level write is greater than the replication factor. So here replication factor was 3. When I write with quorum, I expect 2 over 3 nodes to get the acknowledgement. So 2. Same for read. 2 plus 2 is 4. Greater than 3. We're good to go. We will ensure immediate consistency.
Yep. It's very important to understand what consistency level is defined on a per query basis. So by default, it's quorum. Then you run read with default consistency level, when you run write with default consistency level, you will always have immediate consistency. By the way, that's why I don't like definition of a Cassandra as eventually consistent database. With the default settings, you are having immediate consistency, which is basically the same. So that's a terminology question, let's say. But what's important to understand? Very same application works with data of a different importance and the different priority. Let's say an application working with financial data and working with credentials and working with, I don't know, things like user nickname or profile picture. Those all are different kinds of data, and where we can treat them differently. And for example, when I'm asking for my account statement, when I ask for how much money I have left on my bank account, I don't want to run on the consistency level 1 because, well, I want to know exactly the current situation right now. So I definitely go with write quorum, read quorum for those kinds of operation. But when my application opens my profile with my profile picture or a picture of my friend, like let's say in social network, I'm very fine if it will be an old picture which has been updated half second ago. No tragedy will happen if I will open a picture from a half which was updated half second ago. In this case, I can go with consistency level read 1, which will be updated at some point, but that's a date of secondary importance. So I tend to get it quicker with paying for that with a small chance of eventual consistency. And you define this consistency level at the query basis. When you run a query in your application, you may explicitly specify this one I want to be executed at the consistency level quorum, and now do the same query again, but with a consistency level 1 or any, and that's completely on you to decide how it should be executed and which kind of data you treat right now.
Exactly. Okay, so now the slide you need to show to your CTO or architect in chief. What are the good use cases for Cassandra? And I could have shown this slide right in the beginning, but my purpose is really to make you understand why those use cases fit Cassandra architectures. So first, all about scalability, high throughput, add new nodes, more capacity, add new nodes. So you will use this capability for use case with high throughput, high volume, which are every read, every write, which are event streaming, Internet of Things, log analytics, any kind of time series. And this is one of the reasons you might have heard that, Apache Cassandra is a good fit for time series. Yeah, very high throughput, very high volume, totally fine. Second range is availability. I told you, you cannot lose any data. You lost a node, it's not a big deal. The node comes back, self-healing, and system is still responsive. So mission critical, no data loss, and always on. So this one is most of use case, to be honest, but why not caching, distributed caching? Why not? Nodes all around the planet, insert the value, it's replicated everywhere. So could work for market data, pricing, any kind of repository inventory. It's distributed, so global present. If you are a worldwide company and have data center distributed all around the world, okay, no brainer, having Cassandra there and the data is replicated for you in 2 ways. GDPR compliant, having dedicated nodes on dedicated geographical region with laws, and comply with those with the laws. So of course, banking, retail, tracking, logistics, customer experience. So in the UK, for instance, Monzo is a pretty popular bank, if not the most now. And Monzo has communicated this year and last year that most of the data are stored in Cassandra, to be honest. Even mobile payments and customer account, everything lives on Cassandra. And last but not least, cloud native. We told you that we are using small nodes, community hardware. The network is not a big deal. We will go as fast as the network can go. So you can install already a configuration multi-cloud or hybrid cloud. And once everything is on the cloud, you will access them through API layer. And we told you before that the driver is very clever. it's pretty easy as well to implement a REST API, GraphQL API, gRPC API like Netflix on top of Cassandra. Very easy. And I think in 3 weeks, we do have a workshop especially on that. So if you're a Java developer, subscribe to the channel. In 3 weeks, how to create a microservice with Java on top of Cassandra.
But if you aren't a Java developer, still subscribe
do
to
it
our channel.
Anyway. I love it. And put a thumb up. Yeah, we like it. All right. Okay, so let's have a bit of fun now. It was a lot of slides. Let's do a quiz. And after the quiz, we will go to an exercise where you will create your Cassandra instance in the cloud. You don't have to install anything. Ready? So let's go back to menti.com. Hopefully you didn't close this tab or use your app. So me is just switching like that. Pretty convenient, right? And so I will move to first slide of the quiz. So let me go to the home page of the quiz.
Yep. So again, please answer our questions at menti.com using code 640466. Very easy to go with your mobile phone.
Yes.
And press thumbs up so we will know you're ready. So, who is going to win the prize?
Yes, so for the first part of the quiz, it's 7 questions. Then we will do exercise, new chapter, then 3 questions, and in the end, 2 questions. And I've marked the question now with numbers, so we should be good to go. I hope so. Okay, so I'm about to start the quiz. So when I do that, you can enter your name. So I will give you a bit of time to enter your name. And okay. Boom, boom, boom. Okay, wrong answer, give 0 point. The fastest you go, the better.
But it's still important to answer correctly, not only fast.
Yes.
Sorry. Oh, we have 300 people already, I see.
Yeah, we do have 300
Great.
people. So that will be, performance test for Mentimeter. Okay, so it keeps rising. So I will start the quiz. Alex, can you read the question when they show up?
Yep.
Okay. 3, 2, 1.
How many master nodes does Cassandra require? At least 3. Known Cassandra is a masterless system. Enough to maintain consistency. Seriously, why are you making me think?
And boom!
Yes!
Known.
Yes!
Good. 200.
We did our job well. Now we know how many master nodes does Cassandra require. Cassandra does not require any master nodes because Cassandra does not have any master nodes. Correct answer is Cassandra is a masterless system. People, notice, I see 44 people answered at least 3, which is not a correct answer. Number 3 we were talking of is a replication factor and replica nodes, and you may have as much replica nodes as you want. 1, 3, 5, 7, 100. We recommend to have 3 or 5. But still, it's have no relation to master nodes. Those are replica nodes. Let's move on.
Yes, so each time we do have a leaderboard like that, and we know who was the fastest.
Who was the fastest?
It's close. Taylor Swift again?
Yeah, Taylor Swift.
I mean,
Jovica Andrich?
We do have Taylor Swift every week.
Okay, Irfman. Let's move on.
Let's move to question number 2.
And the question is, in Cassandra, How is data distributed? Partitions. Data is copied to every node. Address locators through the mail, like email or
I
paper
like the
mail.
mail. Postal
Yeah.
address.
Well, that's an electronic database, so mostly probably it's an email, I think. That looks the most reliable way to me.
Yeah, again. Woo!
Yes, yes.
You know, Alex, we should be paid by the number of good answers, you know?
Yeah, that's the best metric I've ever seen. So we have 235 people answered partition, which is a correct answer. Congrats. And I see for 54 people answered data is copied to every node. Hey, everyone, focus please. Data is, take a look. Apple has more than 100,000 nodes, like close to 200,000 nodes. Do you think they copy their data to every node, so every node has the same data? That's obviously makes no sense. So data is copied to every replica node. Every replica node is responsible for the set of data it stores. So you copy data as much times as your replication factor.
Okay, so who was the fastest? Oh, we lost Taylor Swift.
Oh.
Boom! And now Mutlu Polakan, I hope I pronounced correctly, is
Mutlu
now our
Palatkan.
new leaders.
Congrats!
So remember, the 3 leaders will get free swag shipped, and you know, Jack Fryer on Discord is a guy to contact to reclaim your prize.
Yeah.
Okay.
And that's so interesting to see so many different names, because take a look, as we are truly international with those workshops. I want just to mention what we have people from nearly all the countries of Europe. We have people from India. We have people from Africa, from Kenya. I've seen some people writing Kenya, Nigeria, and so on. Like, that's very 21st century. Great, and welcome everyone.
That's very cool, really. Okay, next question.
And the question is, how do you scale up a Cassandra database? Add faster hardware, increase the scale factor, add more nodes, stack nodes until they reach the desired height. My God, who wrote that?
This is vertically scaling, I guess.
Vertical scaling. Okay, now I get it.
Yeah.
Yes.
Very good.
Correct answer is, how do you scale up a Cassandra database? 1 to scale up, add more nodes. 1 to scale down, decommission some nodes. And people answer it, increase the scale factor. There is no scale factor by itself. There is a replication factor which kind of relates to it, but not directly, let's say. And some people answer it, add faster hardware. Add faster hardware is the vertical scaling. That's the way to do your system more expensive, bit more performant, but still keeping less amount of nodes, so you can reach into some troubles. We tend to do horizontal scaling, so add more commodity nodes.
Yep, horizontal scaling. And so Laserboard, I love those animated dashboards. Okay, I think David just moved to 3rd place now. All right, next question.
What is the recommended replication factor? 5, 3, 4, 1.
42.
42, yeah.
Yeah. Even if I agree that it should always be a good answer, it's not this time, sorry.
Time is up.
Okay.
And the correct answer is 3. In some cases, you may need 5, but the default recommended replication factor for most of the use cases is 3.
Yes.
And let's take a look at the leaderboard.
Oh, Salvador was very quick, seems like.
Yeah.
Wow.
Oh,
Yeah,
it was a mistake.
no,
Yeah.
no surprise.
So, first
So,
name at this point is Salvador Valdeolivas. I'm sorry if I'm pronouncing it wrong. Second place, Mutlu Polatkan. Hey, keep going.
yes.
Perovic, yeah, is the third place. Yes, so
All
we
right.
have a tight competition here.
Yes. We did 4, 3 remaining, I guess. Next question.
So the question is, a Cassandra database can be deployed on AWS only, any combination of on-premise and cloud provider, only one of the following: on-premise, AWS, Azure, or Google Compute Platform, a live raft in the case of emergency. Well, with a set of Raspberry Pis and Cassandra, I can definitely deploy Cassandra at the live raft. But the correct answer is any combination of on-premise and cloud providers. And I see some people answer it only one of the following. 36 people. Hey, Cedric, it looks like we did our job not perfectly. Take a look. 36 people answer it with only one of the following. Hey, please. Nope, you can deploy Cassandra at the same time at AWS, GCP, your own server, Raspberry Pi set on the live raft, everywhere. Cassandra is platform agnostic, operating system agnostic, and any cloud agnostic, so you can deploy it everywhere and have all your nodes working together. The only golden rule we recommend you to use is to keep the nodes of the same performance. So don't tend to use some nodes are very powerful and some of them are to be Raspberry Pis. That may
Yes.
lead to some issues. Try to keep them of the same performance. But the correct answer is any combination.
Yeah, multi-cloud. Yeah, don't be too rude. Those guys, just take fun here.
Well,
Okay.
I take it personally. I take it personally. Sorry.
No, come on. Multi-cloud, yes, you can install that stuff. Oh, again, Salvador is on fire.
Yeah.
That's a very close competition.
Yeah.
Wow.
Take a look, such a difference. They're going very close. Salvador is still on the first place. Mutlu is handing the second one. And the new name, I believe, Sri Ram at the third one. And 1 point below is Lek Gyovak. I hope I pronounced it right. Sorry if I pronounced it wrong. Next question is, the CAP theorem states what in a failure scenario with a distributed system. Answer 1, consistency, availability, and partition tolerance are all achieved. Answer 2, only availability is achieved. Answer 3, only 2 of the 3 guarantees are achieved. And last one, I should buy a new cap.
I love it. So the question was fired a bit quickly. Yeah, sorry about that. Okay, only 2 of the 3 guarantee are achieved. Yes, you cannot do everything at the same time. You need to pick 2 of the 3.
It was a trap. It was a trap, people, and a lot of people got into that. Take a look. Consistency, availability, and partition tolerance are all achieved is a wrong answer because you can achieve only 2 out of 3. That's what CAP theorem states. It was a trap. You tried to answer too fast.
Yes, so let's see how it goes.
Oh, I expect some changes.
Yeah. Oh, Sriram was the fastest this time.
Good.
It should move from 3 to, yes, 1 expected. Good job.
So changes on the leaderboard, people.
Yeah, you know what? We put so much pressure on Salvador and Mutlu that now they just click first sentence, maybe. Oh, geez.
Yeah. Okay. So the new list, Sriram is the number 1, Lek Gyovak at number 2, and RS at the number 3, and some more people are getting very close. Okay.
Yes. So last question for this first part about Cassandra fundamentals, and then we switch to exercise. Okay.
Yeah. The recommended way to achieve immediate consistency is to use read-write 1-1, read-write 1-all, read-write quorum with a video chat between coworkers. Well, may work as well. Well, you see, obviously Cassandra Notes does not use a video chat, but they use a Paxos protocol to reach the answers. So correct answer is the recommended way to achieve immediate consistency, and the default way to achieve immediate consistency is quorum. The answer number 2, read-write 1-all, is technically also correct, because with read-1, write-all, you will also have immediate consistency. But it's not the recommended way, because
exactly.
Recommended way is quorum. So those who answer once 1-all, it will work, but you may lose your high availability. And answer 1-1 is definitely not the way to achieve immediate consistency.
Yes, and so that would be the final leaderboard for part 1. And okay.
Oh,
and
it was a wrong answer.
Wow, so close. Okay, guys,
yes.
And now the 3 leaders can reclaim their prize to Jack Fryer on Discord to get the swag, MP with postal address. We will come back to the same quiz right after this few exercise. So don't close the Mentimeter tab yet. We will come back to it later.
Yep, and our congrats to Sri Ram, Lech Jovak, and Vedant, who reached the place 3 in the very last question. Good job. Just keep going and do your job. Guys, contact Jack Fryer at Discord. You have the link.
Yep.
That's the link to join the Discord. Yes.
Okay. So congrats. Let's move to now a small exercise. I talk a lot about Cassandra, what it does. DataStax provide Astra. Astra.datastacks.com is Cassandra as a service in the cloud. You don't have to install anything. We provide both the Cassandra database and tools to develop on top of it, like DataStax Studio. And you will work today with DataStax Studio. So we will use SQL, Cassandra Query Language, the Studio, and we can also use any of the driver to work with Astra. So let's go. Exercise 1, create your Astra instance. And to do so, go to the, the link has been shared on Discord and YouTube, I guess, but I will show you as well where to go. So I quit, I go to the GitHub repo. So let me hide you, Alex, sorry. Here it is.
No worries.
Data Academy /Cassandra-workshop-online. I did not lie to you. All the slides and presentation are there. What you need to do is to go to exercises and 1, how to create an Astra instance. And this is this link that has been shared on YouTube, Discord, and everywhere. Okay, so I will follow the instruction in front of you, and let's do this all together.
Yep, Cedric, I see some people asking for 3 minutes break. I don't know. Maybe we will do the break after the exercise, like 3 minutes.
Yes.
Yeah. So we do the break after the exercise.
All right. Okay, so I'm going to astra.datastacks.com. Oh, I'm already, so let me go with the start. If you don't have any account, which is probably your case, you can either use your GitHub account or Google account. And if you don't have any of those, you go to register and provide emails as usual, very plain old way of doing it. And once you are registered, validated the link from email, you can now enter your email and log into the platform. If you are like me and you do not have created any database yet, this is the screen you will get. Astra
Cedric, I'm very sorry for interrupting you, but I want to highlight people during the exercises. We get a lot of issues with some people who don't follow the instructions given by Cedric. Now, please all focus on Cedric, all eyes on Cedric, and listen and watch what he is doing, because really, when 100 of people misunderstand the instructions, do something wrong, and then exercise doesn't work for them. Please focus now. Sorry, Cedric, but I believe it's important.
Yeah, of course. You need to make it right right now. So remember, I'm using astra.datastax.com, and to have the values I need to provide here, they're on GitHub, and this is the DataStax Academy Cassandra Workshop Online exercise 1, create Astra instance. It has been shared on Discord again, and so it will go through all the steps, and the values you need to provide are there. It's not mandatory to provide those values, but later on we will do exercise, and those exercises expect you to have these values, so you can still edit the exercise later on, but why not having the proper values right now? Okay, so I will use a free tier. Okay, it's a real free tier, free forever. That means even with this workshop done in 2 hours, well, the database is still there and will remain there for you. So you do the exercise, but maybe later on you do have your own personal project. You can go there, create new tables, and working with that, it's free tier. So select a location. Well, it's a EMEA special, so I guess we will mostly all use Europe-West 1. It's free, so I don't care about per hours per month. 0 is still 0, right? So the database name is Killer Video Cluster. But I'm a developer, so I am lazy, which is a strength.
Yeah, laziness is a strength for a developer.
Yes.
So he is going to copy paste values from the instructions we gave, and basically you should do the same. Database name is Killer Video Cluster, and key space name is Killer Video. Key space name is Killer Video.
Without E. K-I-L-L-R-V-I-D-E-O. So
I will write it to a chat.
Yes. Oh, that's a good point. Yeah, you should write it to the slide. So, and also the username kvuser, and the password is kvpassword. Okay, so I cannot. So kvpass. Okay, kvpassword, and do the same kv with capital K, capital V. So if both my passwords are the same, I can now launch the database. So when I launch the database, Astra will give me a 3-node cluster or 1-node cluster, depending on the configuration I've created, I've asked. It may take a few minutes, let's say up to 10 minutes. Remember, we now are 300 login to creating some database at the same time. So have a little patience, 10 minutes should be totally fine. And this is also the reason why taking a break now, it's a pretty good idea, right?
Yep. So if you see the text database is initializing, you will receive an email when the database is ready. You can have your 3 minutes break. And if you are not yet, please create your database.
So let's do a 3-minute break.
Yeah, should be enough.
and I will keep sharing the values to put. Okay, like that I can watch at the stream. And Alex, I see that we do have more than 400 people on the live stream on YouTube now, which is nice.
Yeah, that's really great. We have 445 concrete viewers on YouTube and some more on Twitch. And that really makes me happy.
Yes. So if you like the content, don't forget to subscribe, leave a comment, put a thumb up. It helps us a lot to make the channel grow. We are doing those workshops every single weeks, and we change content each time. So for the first one, in EMEA time zone, I think it's the second one, Core Cassandra, but more content's coming. We can do machine learning, we can do Kubernetes, we can do Kafka. We do have a lot of content ready to go. So in the very last question of the survey, you should, type what you need us to show during those workshops in the next sessions.
Yep. I see a question at YouTube chat by Vika Spatney. I do not have a free tier option. Usually it happens if you have used a free tier option already. So you have one database on a free tier already. Easiest way to get the new one for this workshop is to basically delete old one if you don't use it. And then this free tier option will be available again. Very easy.
Yes, the free tier is really, you have a single free tier. And once done, this is what it should look like. Okay. You don't have, hopefully you don't have this sound, telling me that the alarm is ready.
Yes, we have. Yes, we have.
Okay. So that means that the break is ended. Hopefully you get enough time to pick a drink. So let's go back to business.
Yep.
And so in the slide deck, you can see that I put exercise 2 right after exercise 1, and that's a good call because we are in Astra. Why not using Astra right here? There is nothing special about this exercise number 1 or number 2. We did number 0, number 1, now it's number 2. Yeah. We're starting like Java at 0. It is funny. Okay, so people, for this exercise number 2, again, we will share link on every platform as we used to do, Discord, YouTube. I will use Developer Studio. So on the main screen of your Astra, there is Developer Studio here. I will simply click the launch now. I will enable JavaScript for this guy because I've disabled JavaScript by default. And I will be asked to provide yet again my login and password. So remember, kv user, kv password. Oops. Kv p. And the reason is Astra is a platform with multiple services. Studio is one of them. So I need to provide the user password yet again. But I need to do it only once. Okay. So to do the exercise, and it will be the same for every single exercise. You go to the zip you just downloaded from GitHub repo, okay? You go to notebooks, and you will drag and drop the notebook inside the studio window. And that's it. It will be imported. You can also try to import using add notebooks and provide the URL of the GitHub file, but that's very, very more convenient to just drag and drop, just to be sure you actually have a real tar file and not some fancy web page and not the expected file you need. So this is also the reason why I ask you to download the zip or git clone the repo in the beginning of the workshop. It's easier like that. And you can import one file at a time. So here I will do DataStax Studio like that, drag and drop, and here it is. My notebook has been imported. To go back to the home page, I can click on the main menu on the left top hand corner, see notebooks, and see that my notebooks is now there.
This step
Question?
makes issues sometimes. So once again, if you at this point don't understand what to do, you first open Developer Studio at the page of your Astra instance. Can you, Cedric, could you please open Astra instance once more?
Mm-hmm.
And there is a button to launch Studio, launch now. Developer Studio, launch now. Now, Developer Studio, launch now at the page of your Astra database. Now, after that, or before that, if you are, you have to download this repo, Cassandra Workshop Online, as a zip file or clone it with Git. If you have Git, doesn't matter. You will have tar files. So those tar files are in the folder notebook are exactly the files you have to upload to your studio. At the notebook page of your studio, just copy paste your tar files and you will have your exercises loaded.
Yes, so download zip from GitHub. No, not yet the laserboard. Go back to Astra, launch Developer Studio, and here it is. Again, you show up. Let me hide you. Okay, and I will simply import one file after the other. But for exercise 2, well, we need to import simply Cassandra Developer Workshop -2. So this one is very, very easy. It's each time those are standalone notebooks. You don't need us to go through the exercise. Those are very well explained, both explaining what to do, what is the solution, and why the solution is like that. So each time you just try to expand, to get the solution like I do. For every notebook, you will have a first empty cell, like this one, the one I am showing below the huge red arrow. So all the code we need to start the exercise is there. So if I open it, you can see that there are some code here. Use killer video, this is the key space we just created. Create a table and drop the table. So basically, this stuff do nothing. Create something and drop something. But this is just to show you that for every single notebook, go there and execute by clicking Run Cell on the top right-hand corner of the cell, like that. I click. As you can see, there is a running bar on the side telling me that we are currently executing the cell. And when it's done, we should have a message telling it's ready. Okay, what? create if not exist, drop table, first table. Well, there should not be any issue with that. Okay. Oh, that's surprising. Why did I get this error? I shouldn't ask because I just created one statement. I created the table with the first statement and dropped the table with the second statement. That's weird. That's weird. That's happened, but at least, I understand that. Maybe the statements are triggered at the same times. No, that's a weird behavior. Anyway, the purpose here is to understand what we are doing. And you know what? I can do some comment here. Now I'm hiding drop table, as you can see. I run the cell again. And if I click on schema on here on the top right hand corner, you can see that I do have the killer video schema table, and this is my first table show up, and I can browse my tables. Okay, but if you do not put the last line in comment as I did, well, you don't have anything in the schema. So tables is now empty. Okay, so moving, I won't go through all the exercise. It's really how to use the notebook. So first is use the markdown editor. When you see some cell, some are Cassandra code, CQL, Cassandra Query Language. Some are simply text or documentation in markdown. And so the first part is all about, see, hello, your name goes here. So the idea is I go to the show editor code, I see my hello, this is my hello, and I will put my name, okay? And I go back here and I execute the cell. When I execute a markdown cell, the documentation is updated. I will go quick because this is really about using the studio, not really about understanding how to do some Cassandra tables, which is the next chapter. So let's go it quick. This one is describe key space. Could be interesting just to see that we do have key space and system key space creating for us by Astra, and user-defined key space killer video. So some info how to use the studio. Okay, here I show my studio, how to help, and want to feel like a Jedi. Boom, this is here you go. So it's really all about using the studio. Exercise number 3 will be really create tables, do some stuff. But hey, before creating some tables, you need to learn how to do it. And I will let Alex now driving the data modeling part.
Yep. So give me a second. I will switch it to my screen. And we go. Yes. So once again, hello everyone. That's Alex Voloshev, developer advocate at DataStax. And we are switching to step 3, data modeling with Apache Cassandra. And data modeling with Apache Cassandra is a very special and very important step. Why? Well, take a look. When you work with Cassandra, you usually use CQL, Cassandra Query Language. And it's designed to be very similar to SQL, so to make it easier for you to learn, it still has the same select, insert, update, and so on. And it has one very good side. You can easily learn it because basically you've used it very familiar thing, very the same thing before. Mostly probably you know SQL already. And it also have very strong down point, the negative side. Most people start to think, oh, it looks so familiar. I know how to use it. Let's go. Let's use Cassandra. I already know how to use it, and it's a trap. Although CQL is indeed very similar to SQL, Cassandra is different. especially by its design and data model. And people who think, oh, it looks familiar, I can do Cassandra, mostly probably are wrong, because when working with Cassandra and developing and designing your system with Cassandra, it's not the same as with traditional relational databases. So what you have to remember, it's different, and Cassandra offers really a lot of great benefits, highest availability, highest performance, it's an incredible database. But if you do your data model wrong, you can ruin everything. If you want to do things wrong and make your Cassandra database slow, data model done wrong is the best way to achieve this goal, seriously. So let's focus on the data model, let's do it right. And we go. So, as we mentioned before, the core access unit in Cassandra is a partition. In general, Cassandra structure, Cassandra data looks very familiar as any data structure you have in any another relational database. So we still have the tables, we have rows and columns, and the key space is a container for the tables, as the database in relational database is a container for tables. So it looks very familiar so far, except of one thing. Then you start to think of the data and working data in a relational database, like MySQL or PostgreSQL or Oracle, doesn't matter. It's still the same. You specify database, you specify table, you specify columns and rows. So your query may look like select username from database point table name users, where ID equals 5. Looks familiar. In Cassandra, you have one very special unit you must consider. And then I say must, I mean that exactly. As I said in the very beginning, Cassandra is big data ready. What is a big data? There are a lot of definitions. One I like, simple but very efficient. Big data is a data which doesn't fit to a single, even powerful server.
Yeah, I like this definition as well.
Yeah, we have so huge scientific explanations on Wikipedia, but most of them are, how to say, overcomplicated. I prefer simple definitions. So, and when you start to work with bigger and bigger data on your relational database, at some point you go with sharding because it doesn't fit to a single machine. And instead of shards, those are, let's say, non-native and bring a lot of issues by design. We go with partitions. And all the data is grouped to partitions based on the partition key. And as it shows, we have here the same columns, rows, but rows are grouped into the partitions. And partition is a thing which is stored together on a server. So in this case, we have a partition X, and all the rows in the partition X will be stored onto the same server and the same partition, so it's very easy to retrieve them. So remember, first rule of a partition, we try to store together what we retrieve together. For example, I have video at YouTube or at Killer Video. It's our reference application showing how to work with Cassandra. It's kind of a clone of YouTube, or let's say competitor of YouTube.
Yeah, they cheat on us.
yeah, all the time. Good.
Killervideo.com.
Killervideo.com. Yes, and I have a video, and every video has comments, and people write comments to this video. What's the most common situation? A user opens a video page, and below it, all the comments, usually sorted by the timestamp, time date when this comment was right, newest first. That's the typical situation of a partition. So one partition has, we partition those comments by video ID, because every comment must have video ID. And when we store them together and retrieve them together, and despite we may have, I don't know, 50,000 of comments for a video, they are stored on a single partition. They are just text entries, so they aren't so big. It's not a problem to have this partition. And we retrieve this partition and show it as just a single request to a single particular server. As I said before, driver knows schema allocation on the cluster. Driver knows which node to ask. That's one of the ways to group the data into the partitions. Example data. Users organized by city. So we have key space users and tables users by city. In this case, as you see at this partition, we have a typical users list with the last name, first name, address, email, and so on. And also every user has a city, which is a sign for us, which is a partition key. So we group our users by a city. Now we start to think, okay, we grouped our users by cities, which brings us to the second rule of the partitions. Take a look. Let's think together a little bit if it's a good partition key or not. In the beginning, it looks not so bad. So I can retrieve all my users by a city altogether. Let's imagine I need this information. But there are some cities in the world with like 3, 4, 5 inhabitants, and like very small cities and towns with a few dozens of them. And meanwhile, we have some cities like in India, for example, or in China, with literally dozens of billions of people. And what we have in the end? All the partitions are stored evenly across the cluster. And then we have a situation as some of the partitions are going to be hotspots. They have like, I don't know, Mumbai with really a lot of people. Servers storing those partitions, let's say we have replication factor 3, so this partition will be replicated 3 times. Those 3 poor servers will be very busy. And servers responsible for the cities like the, I don't know, village where I'm living, like right now, Ziegelbach, it's like 1,000 citizens. And obviously those servers are going to idle all the time. Lazy servers. That's me, engineer, who should be lazy, not servers. And what's happened? We come to the second rule of the partition. We separate our data into a partition to avoid hotspots and also to avoid 2 big partitions. Now, I want you to think, and I will do you a job, not an exercise, no quiz, but you still have to think and write your answer in Discord on at YouTube chat. Imagine we work at a huge telecommunication company altogether. Those telecommunication company transfers really a lot of data from one continent to another, like streaming video, streaming TV, and so on and so forth. Really a lot of network operations all across the world. And therefore, we have a lot of infrastructure and hardware all across the world. Server rooms, data centers, routers, and so on and so forth, like everything what relates to data transfer. And by the way, it's a real situation, so I'm not thinking of it, but just a real story. I will call no names, but it happened in real life. Yep. So take a look. You can't control what you cannot measure. To understand the situation of our infrastructure, we have billions and billions of sensors everywhere. Those sensors are reporting some data. For example, temperature sensor reporting temperature. Humidity sensor reports humidity, and so on. And we have a lot of them in all the server rooms all across the world what we are having. And every sensor reports every 10 seconds. Sensor ID. So what's my name? I am a sensor number 535666665. And time of event, like when this value was registered. And finally, the value. So like its temperature or humidity or anything, whatever you can imagine sensor reporting. And we have to design a data model for this table. As Cassandra developers, novice Cassandra developers, we already know what we have to partition our data in the way what we store together, what we retrieve together. And we start to think, what's going to be a good partition key for this partition? Okay, I store together what I retrieve together. Usually I retrieve a story of the values for a particular sensor, like I'm interested into the temperature for the last 2 weeks in server room number 513. I know the sensor ID, and therefore I will use sensor ID as a partition key. And when we have a table consisting of sensor ID, time, and value. And every sensor stores its data to the Cassandra to a table organized like this: sensor ID, timestamp, value, every 10 seconds. Partition it by sensor ID. And it works well first few months, and when I run into troubles. Now please think and write your answer into YouTube or Discord on what exactly happened and why I ran into issue. What went wrong?
Let's see. It's typing on Discord. I can see too much data in Node. Yeah, Crazy Danny got it right, I guess.
Let me take a look. Yes, I already see the
Matteo,
correct answers.
Yeah, Matteo Barberi on YouTube.
Yeah, Matteo Barbieri on YouTube. Partition is too big. Correct. So I cannot see all the. Yeah, I cannot see all the answers.
There are a lot.
Yes, there are a lot of answers. And I will answer you. Yes, partition is not defined correctly. Partition, okay, we have, so by the way, that's interesting, so many answers. I want to answer and comment some of them. So, take a look. Correct answer first. What exactly happened? In the beginning, everything went well, but sensors report their status every 10 seconds. And as a result, after some months, we even can calculate how much time went. Partitions are getting too big. By itself is not so much disaster, but then as partitions store it together to be able to retrieve together simply, it's stored in a file, obviously together. And then partition is getting too big. It becomes very hard for Cassandra to maintain those files as they are too big. And for example, then you are adding a new node, the huge file has to be transferred. So servers busy sending information. It's hard to repack this information. There is a maintenance mechanism like compaction needed to handle this data, and it's very hard to handle so big files. Also, I want to comment wrong answers. Well, maybe not wrong, but not perfect answers. Answer was too many partitions. No, it's not a problem. You may have as much partitions as you want. So partitions aren't limited by the amount of partitions. It's not a problem. Too many data in one partition. It's correct. It will be a bad practice to assign ID as a partition. No, by itself, ID as a partition key, it's fine. You may have, for example, table users having partition ID as a user ID, universally unique ID, and it still will be fine. Don't worry. Hotspots, nope. Let's remember how partition works. Partition key is being hashed with murmur-free hasher partitioner. So basically, there will be no hotspots as all the sensors work with the same intensity. So no, hotspot is not the issue in this case. Good, and I already see some nice suggestions how to solve it. It was my second question, how we could solve it. And to specify how we could solve it, we can go to the next slide. It's not this slide. Yeah, we will go to this slide. In this case, we have a create table statement, user by city, specifying city text, last name, first name, address, email. And then in the last line, take a look, primary key, city, last name, first name. Those city in this case is the partition key. See how it's specified in the very beginning with breaks and with brackets. And city is in this case a partition ID. But I also may have, that's a suggestion for you to think about, a composite partition key. Composite partition key consists of one row and second row. So you may add one more row to your partition key to be it composite, and then it will be hashed together, and unique partition ID, hashed partition ID, it's like hashing with a salt. If you know this concept, you just add the salt when hashing your password, for example. It's the same idea. And then you will have a better partition key. And I already see the almost correct answer. Take a look. In the case of our sensors, the suggested solution was to use year and month as a string. Like, for example, it's May of year 2020, and in this case, the synthetical string will be 052020 because it's May 05 of year 2020, 2020. And next month will be 04062020. What it gives us, as we having a partition key out of sensor ID and month, we will have our partitions never too big, because as soon as month is over, we have a new month and we will create a new partition based on that. First point. And second point, some people suggested to use things like date, time, minute, hour, and so on. Although it may look good, but it also brings some troubles. Don't forget, when you're doing a query, you must specify a full partition key. And if your partition is sensor ID and month, it's not a problem. But if your partition is sensor ID and month and day and hour and minute, therefore you have to specify all of them in your query. And don't forget, partition keys do not support inequalities. So therefore you have to specify them explicitly. And then you are going to retrieve your data for a week. You will have to specify all the hours in this week, which is obviously not convenient. So the best solution in our case was to use a synthetical partition key based on the sensor ID and month and year of this of the time of occurrence. Let's make a step back. So the idea what table holds many partitions, I've explained it already. Yes. Good. So I said so many words about the partitions, and still, there's a 2-3 hours workshop overview level with Cassandra. Cassandra is a very powerful, but not so easy to master tool. So if you are going to use Cassandra live, what you have to do after this workshop, first, claim your voucher to pass the certification and be a certified Cassandra developer. It really boosts your salary. I can say Cassandra developers are in a very high demand. Huge companies like Netflix, Instagram, and so on, only growing their usage of Cassandra, and they may need new people. Second, after claiming your voucher, you will have 30 days to get ready for the certification. 30 days. You go to the academy.datastacks.com and register for our free Cassandra courses. Depending on your specialization, if you're a developer or admin, take the proper path. I expect most of the people here to be developers, and therefore get the developer path. It's free courses altogether, around 20 hours, I believe. And after that, you will be ready for the certification, and it's all for free. That's incredible. Question how to get voucher. I kindly ask one of our friends to copy paste into the YouTube chat and Discord chat link to get voucher. Thank you.
I think they did already. Yeah.
After Perfect. That, you will be ready to pass the exam. That's a very good time to say thank you, DataStax. Okay, let's move on. Next thing, we discussed data model a little bit. Let's talk about how we create a key space in Cassandra Query Language, CQL. So we have, in this case, an example how we create a key space users with replication. Then you create a key space, which is a container for tables. You need to specify, you must specify two things, three things. First, you must specify key space name, which is just a string for you, and replication strategy and replication factor by data center. So, what's the replication strategy? Easy to say. We currently having two replication strategies. One is called simple strategy, and one is called network topology strategy, as you see at the screen. So, simple strategy is good for your laptop and bad for anything else. You definitely don't want your administrators to run Cassandra with simple strategy in production. Please, that's only for development. And network topology strategy, as it says in the name, it's a network topology aware strategy. So it's a strategy of deployment which considers a network topology. For example, it considers your data centers. It considers servers racks in your data centers and spreads data, replicas over the data centers and server racks properly. And if you are deploying in the cloud, like AWS, for example, we use network topology strategy also with, for example, AWS Snitch. Snitches are about administrators, so it's a developer's course. I will not explain it so much, but we have, for example, an AWS Snitch, which is responsible to put data, replica data properly in the cloud. And it will use, instead of server racks, it will use availability zones. And instead of regular data centers, it will use AWS data centers. If we speak about AWS, same for the other clouds. So on the production, on staging, we usually go with network topology strategy. And then we specify replication factor per data center. In this case, I'm creating a key space users with replication network topology strategy. I'm going to put the data only to the data center 1 with replication factor 3. If I would like to have data center 2, I have to add it right here, and I can specify another replication factor. For example, I use data center 1 for the real production workloads for my customers to work with. And I'm having data center 2 for only analytics workload. So only there will be Apache Cassandra, Apache Spark, and only search and analytic queries from my analytics department. Then I don't need to have so much replication factor there because I don't need so much high availability. And I set, for example, replication factor 1. So what's important to understand, I specify replication factor for a key space per data center.
Yes, and remember the multi-cloud or hybrid cloud deployment. If you add a new data center, you simply say alter key space and change the replication, and Cassandra will start to stream the data to the newcomer like that. After a few commands, but like that, simply. Single command.
Yep. It looks like we have a little issue with the voucher link. People report it's unavailable and some issues with Google Docs.
Yeah, so I will let Jack and David answer this, and we will move forward just to reach the exercise, I guess.
So for me, link works. If the link doesn't work for you, try again later. And if link still doesn't work, then contact Jack Fryer at Discord, and he will handle it.
Yeah, like is okay.
Yeah.
All right.
So for me, link works. Good. So what's next?
I think we will move to an exercise because we did the key space.
Yep.
And the create tables, so we can move to exercise number 3.
Just a second. One last thing. Creating a table in SQL. I explained it briefly. I want to add 2 more things.
Okay.
So as you see, syntax to create table in Cassandra is very similar to syntax in any SQL language. So we create table, we specify key space, we specify table name, we specify fields like city will be text, last name will be text, amount of inhabitants will be integer. So this one all very familiar. What different? In the end, last line, primary key. Primary key consists of partition key and clustering columns. And all 3 those concepts have different duties, and you have to understand them all. We talked a lot about the partition key, but we haven't discussed primary key and clustering columns. I will be very brief because, well, primary key is a very simple idea. In the relational databases working with not so much of data, you can ask a database to create an ID for this row you are creating, for the data you are inserting, like sequential ID. Although it's a nice concept, it's not going to work very well when you are having 10,000 of servers responsible for storage of your data. Basically, they will have to agree on the sequential ID they are going to generate, which may take ages under the bad network conditions. So instead of that, you are generating unique values on your site as an unique IDs, universally unique IDs. Some of you may know this concept already, UUID. And that's very often used in Cassandra when you generate a UUID at the application site and then store your data into the database using this UUID. Primary key. Main idea of a primary key is to guarantee uniqueness, so you can always identify the data you stored and to have this data unique. Now, next question for you. There is, again, a tricky question I want you to answer. Take a look at this table. We are creating users by city. And this table has awfully bad primary key. Awfully bad. Why is it bad? Please answer why this primary key is absolutely wrong. I'm waiting for your answers.
Absolutely. Yeah. Yeah. There is a default, main default for big cities. Let's see what it is.
Yeah. So, Cedric, someone has answered it already?
Do not see the correct answer on YouTube yet.
Oh, yeah.
Yes. Matteo Barberi.
By the way, notice it's the same guy who answered it correctly once before. Hey, Matteo, we are hiring. So take a look. Yeah, I see some correct answer already. Exactly. So primary key must ensure uniqueness. And if we have, what's the probability to have 2 John Smiths in the same New York, let's say? Obviously, there are a lot of them. And in this case, primary key is very bad because it doesn't ensure uniqueness. So that's a very bad primary key. Do not design your primary keys like that. Cassandra does upserts. We'll talk about it in a moment. And therefore, if you are having primary key like that, you will overwrite information of your John Smith of New York every time you add a new one. Good. So, and people asked, I say it London. Okay, it's still the same. Issue is still the same.
Not the same. London is London, man.
Oh, yeah. I'm sorry, it makes a big difference.
Yeah.
Okay, so, and take a look. City, in this case, is a partition key. It defines the partition. City, last name, and first name are the columns defining primary key. And they all are text, and that's a very bad primary key, so we do need to add some uniqueness in this primary key. And last name and first name are clustering columns. So clustering columns are the columns defining a sorting order in the partition we have created. For now, it's not the point. And in this case, address and email are data columns, those only responsible for storing data. Good. Now, yeah, let's you do some job.
Yes.
We are working with Cassandra Query Language, finally. Cedric, would you like to do this exercise?
Yeah, sure. I'm sharing my screen. You need to
Give me a second. Give me a second.
do the magic happening, and I will.
I'm on it. Yes, you are live.
Okay. So I'm coming back to the studio. Okay. So yet again, we should have shared the link for exercise number 3, both on YouTube and Discord. But yeah, you don't need this link anymore. You do have all the files ready to go on your machine. And so you will drag and drop exercise number 3 like that. And you know what? We can also import everything right now because we are at it. So this is number 4 and number 5 and number 6. So we won't probably have time to do it all in front of you today, because as you might have seen in exercise 2 already, those are standalone exercises. You simply have to read, answer, and you get the solution in the slides for you in the notebooks ready to go. So I've just imported exercise from 3 to 6. Let's see what number 3 look like briefly. So I may go too fast. Sorry about that. I simply want just illustrate for those who doesn't do the exercise with us, and keep enough time to do our quiz and games afterward. Okay, so again, I'm running the first cell, run cell, and it will create everything I need. So all the table, all the data. I can show you by clicking Show Code Editor. And you can see that now we are creating a bunch of tables with no data for this course, for this notebook. Okay, success. So if I look at the schema, now I do have tons of tables ready to go. So first command is describe key space. We did that before, so I will do it again. So copy paste. To execute a cell, you can do Shift Enter, Shift Return, instead of clicking the Run button each time, as you like. So describe key space, list you all the key space available, most system, and the one you just defined when you create the instance. Okay. I could do the same with killer video. So I can say describe key space killer video. So I go fast here, but just see that a command is double slash. When you execute a SQL statement, put a semicolon in the end, and this is how you get the result, and this is how you get the tables. So as I told you, the solution is self-explaining, and you can come back and read at your pace if you didn't get anything today. So I will describe key space killer video. And this time, not only I will get the name of killer video, but now everything related to the key space. So I do have my replication, remember in the slide? So network topology, CASDC1. So I feel we are using the network topology, but replication factor is 1, which you should expect from a free tier. And you do have all the tables with types, primary key, and all the metadata for this table. So As you can see, Cassandra created a lot of metadata by default. We won't go into each detail today, but all those setup you can see here, you can fine tune what you need per table. Okay, so I've described my key space, yada, yada, yada. And okay, this is a command to create a table. So create table like that. So he explained you how to do that. And this is exactly the table they want me to create. Investigate the primary key. So it seems like the primary key is composed with a single column. So the primary key only contains the partition key, and that's it. No clustering column. So if I create this table, I will go create table if not exist, killervideo.users, providing column, user, first name, last name, created, primary key, user ID. Okay, let's see what it looks like. Okay, and I will copy paste. So see that I do have a single set of brackets, whereas in the slide, we provide you two sets of brackets like that. So I would rather use the double bracket, because now if I need to add a clustering column, I can go like that. And now we can totally differentiate what is the partition key and what is the clustering column. So always use double bracket is a good way to just show people that you know what you are doing. Okay, I've created the user table, and now I can describe the user table. So I can simply say describe table, my table, and I will get the same output as before, but simply for my new users with primary key with a single column, which is it's a partition key here, a UID. So you might notice that the partition key, because it's a UID, you will get a single row per partition. Whereas before, Alex told us that you should store data the way you will retrieve the data. So with this killervideo.users table, the best and maybe the only query to do against this table is get user by ID. And even if it's a single row per partition, it's not a big deal. Partition will be evenly distributed around my rings. And that's a totally good way of implementing single row per partition, because I don't need to provide any more filters or sorting conditions. Okay, and here are commands to insert in my new table. As you can see, instead of providing the full UID, I can use function like UID or to timestamp now to get a timestamp object. And so now I could execute the result by saying run cell, and I will get my result. So you might tell, okay, why did we hide the cell? You say, okay, I want to see how to show this info. And you know what? That's very funny, because we do select star from killervideo.users. And we told you before, oh, please don't do select star from a table, because it does a full scan of your cluster. So, but here, that's a sample, that's a tutorial. So we did it, but we hide it. We know that it's wrong, but hey, we need that to show you. Okay, so insert another user. I will probably stop here just to give us enough time to do the rest. I execute again. Now I do have two records. Okay, when you want. Okay, can you please execute my cell? Okay, I do have two records now. And so I can select from the table. Do not provide any where clause, bad, full scan cluster. But because user ID is my partition key, full primary key, I can use this UID, let's say who I need to retrieve. Christina. So I go here. Christina is the first line. So I will copy Christina ID and paste here. So UID is an object. I don't need to provide any quote, and it will work. Okay. So, and again, it's very well detailed. I won't go too much into the detail, but you do the same for Jeff. Okay. You can update. You can update either single colon, update set emails equal, okay, and get the result. You will update both Jeff email and Christina email. See that you have updated the row, okay, update set, very easy, just copy paste. And for the delete, there is something pretty nice. So if I select, so let me open a new cell, select record. Okay. So I do have Jeff and Christina. Okay. So they want me to delete only the email of Jeff. So I go here and again, I copy paste the Jeff email, the Jeff user ID, sorry, user ID is the partition key. Okay. And I will delete only the email. And now if I execute again, select star, you can see that I have deleted simply the email. It's totally good design for Cassandra to have scarce table. A big number of columns and empty values, totally fine. On the contrary, as relational word, where if you do not provide anything in a column, it will be a null value that will take some space. For Cassandra is partition ID, the partition, and then key value, key value, key value for any extra column. So you can totally drop one of the value, that's totally okay. And if I now delete without providing the column name, I will simply delete the full row like that. And if I execute again the select star, the row is gone. Okay, so, and with this exercise is all about create table, they delete, CRUD. Okay, and now you know the syntax for every operation. Again, I was very fast on purpose. You can go back and do it at your pace. Every exercise is independent. You don't need to do the previous to go forward, but it's very useful.
Yep. So I do recommend you to first watch how Cedric is doing exercises. So see them explain it, and then do all the exercises on your own. Theory is dead without practice, so you really have to do it on your own.
Yep.
Okay, so we are done with the exercise. I think we will proceed with data modeling.
Yes.
Okay, so now I'm live.
Mm-hmm.
Will be in a moment. Yes. Now it's my screen. Good.
Yes, it is.
So, a few words to say about it. What's important for us is what relational modeling is very different to non-relational Cassandra modeling. Oh, sorry. Before I will proceed with the step, I had a really nice question in the chat. I promised to answer on my own live. So, Harsha Rani asked, how do you handle table relational constraints and translation in Cassandra? I guess it was about transactions. But first of all, about table relational constraints and table relations in general. Answer is Cassandra is no relational database, no SQL. And Cassandra does not support relations. And there is a very solid reason for that. Take a look again. If you want to really focus on the relations, and that's the most important thing for you, then we have graph databases. And graph databases are very powerful taking care of the relations. If relations are as important as the data you are storing and you want to handle some low to medium sizes of data, then traditional relational databases may be the best choice for you. And Cassandra is designed to work with tremendous amounts of data, any big data, dozens petabytes of data, hundreds petabytes of data, very, very, very quickly. And that puts some limitations on us. If you want to handle hundreds petabytes of data over dozens, thousands of servers, there is simply no way to guarantee high performant quick answer if you are trying to do remote distributed transactions or remote distributed relations or remote distributed constraints. So we have a price to pay. If you want to work in milliseconds, within milliseconds, with the petabytes of data over the world, there is no way to support transactions and relations and relational constraints. Sorry. So the answer is it's now on the application side, at the developer's side, to take care of these things. That's the price to pay. I'm very sorry, there is no silver bullet.
No.
I'm very sorry. Good. So what I hope I've answered the question about the relational constraints. You may have them in, again, getting back to the unique and great world of unicorns and magic. If your network is always stable, if your power supply is always stable, if your servers never hit any garbage collection, any issues, any whatever things happen in the real world, if you live next door to the unicorns, then you don't have to care about the availability and things like that. You may have distributed transactions, you may have distributed relations, and so on. First thing. And second thing, please send me a ticket to your magic world because I really want to be your neighbor. In the yeah. Okay, I will do, Cedric, as soon as I will get one or two. So as long as you live with me in the real world, there will be network locks, there will be power supply outages, and so on and so forth. And there is always price to pay. That's exactly the thing that CAP theorem says. And it's very same to the CAP theorem. As long as everything works perfectly, you may have distributed transactions and constraints very quickly with no issues. What I'm talking of, you cannot have guaranteed quick responses in the real world with distributed things like that. And that's the decision architecturally done. So we do not do distributed transactions except of lightweight transactions, and we do not do distributed relations. I hope I've answered it. So let's move on. Relational modeling. Now we have to do, so we were speaking about model, but the best way to learn something right is to do something right. So we will speak how exactly we design a data model for a Cassandra-enabled application. Most of you have experience with relational modeling, so I will use it as a base to talk what's different in the Cassandra world. In the relational modeling, we first analyze our data, we first analyze our domain, business domain, and based on the data we have, we create models. So like, let's say we are speaking of an application which is kind of an company management system or enterprise management system, which handles, besides all the other things, employees and departments. And as every employee has first name, last name, works some department, have some salaries, based on this data, we create models. And for example, in this case, we create employees model and department model. Very simple model, as it's a reference. Every employee will have first name and last name. Every department will have just a name, that's enough. And every employee works in one and only one department, which is a normal situation in any company. In this case, we are going to have two tables, employees and departments, and we are having a foreign key to make a relation, establish a relation between them. Every user works in a department. Like let's say Edgar Cott, user ID number 1, works in a department ID number also 1, which is an engineering. And then your application needs the data. It will retrieve the data from a relational model using join. So you go with select, first name, last name, department, from employees, join departments, on foreign key, blah, 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 blah. Relational databases having joins and foreign keys, and that's great, as long as you're having a small to moderate amount of data. And your application run joins. And that's a normalized data model, so call it fifth normal form, and so on and so forth. And you know what? It's really great. I like normalization. The reset, we have to disregard it sometimes. But there are so limitations. With a very strong normalized model, you run into troubles when you have to fetch data, multiple kinds of data from very many different tables. I want to ask you a question one more time. There is a limitation in MySQL join, at least it was like 6 years ago, maybe now it's changed. Please tell me how many joins you may have in a single select statement in MySQL. I'm waiting for the answers at YouTube and Discord. Again, how many joins you may have in a single statement on MySQL, in MySQL, when using MySQL. $256, smaller. 256 is too much.
266 joins, man. You can spend your life doing this.
Hey! Wow. So, Murat Tank Batman, Google says 61. Hey, man, everyone can use Google, but it's a correct answer. And Matteo Barbieri says, yes, 61. Hey, guys, you Googled it, I know. So I can tell you without Googling, because I have like the very bloody scars on my background. I reached this limitation once. Can you imagine this select? 61 join. Exactly. Yes, I do reach this limitation once in my life, indeed, seriously. So that's the consequences of a normalization. Fifth, relational modeling, it's often use case, well, not 61, but with Cassandra, we go in the different way. This way have some benefits and some downsides. As said, when you are working with big data spread it over the world, you have some price to pay and some extra job to do. But wait, hey, Cassandra already does a lot of work for you. You work in a good team. In the Cassandra data modeling, we think exactly opposite way. We first think of application, or I would better say the first think of customers, people, you know, not the cold hardware first or applications first, but the people first. People is what matters. So we think of what the job customers, clients, users, visitors are going to use our application, what are the use cases and how exactly they access our application. Then based on that, I create models. It may look strange, but I will explain it in a minute. And based on those models, I organize my data. So people first, not the hardware or software, but humans first, and humans' behavior first. Respect your customers. In this case, if I'm going to retrieve regularly data of my employees, of my team, I'm going to have a table of ID, first name, last name, and department together. And when I want to get information about in which department Edgar Code works, I simply do one query with no joins, and I'm having an answer immediately. And that's called denormalization. Good thing, I get my data immediately in a single query. and that's very, very fast. So I can get my answers with no joins, no extra conditions, just one query, and I get my data. Good. If something is good, then something is bad. Bad thing happens on the write step, because I have to now do, due to denormalization, I have to do multiple writes to multiple tables. Good news, Cassandra offers a special tool to do it, so-called batch writes or batches, and we will discuss them a few steps later with Cedric, I believe. So then how exactly we work on our data model? How do we create data model? Very step by step. First, we combine two things together. Application workflow, how exactly people are accessing and using our application, what's the typical use cases and use steps for our applications. And then conceptual data model, those are characteristics, values of different objects we are working, or different entities we are working on. And we are mapping them together, workflows to conceptual data model, to create a logical data model. So conceptual data model is about entities and their relations. Application workflow is about queries. Well, we speak about people using our app, but in the end, for the backend, for the database, it all looks like query. And in the Cassandra, query is the queen. You design it all based on the query.
One query, one table. Almost
one query, one table, yes. So, well, there is a tool called Materialized View, but it's considered now experimental, so we don't recommend to use it at production so far. There is a couple of issues to solve before it goes non-experimental anymore. Well, you know, Cassandra is an Apache now project, so it's an open source. So if you want to make it better, go and do it, and we will really appreciate that. So, conceptual data model, in this case, it should look familiar to you for everyone who works with relational database. We have entity user. Every user has ID, email, and some more properties. We also have videos. Every video has ID, title, and description, and some more properties. And user can comment on video, and video can be commented on by a user. And every comment have a timestamp when it happened and text what's the exact comment by itself. And then, based on this conceptual data model, we can move on to application workflow. Yes, so yes, as you see, we are. Oh yeah, sorry, Cedric, go on.
No, I just said we told you 10 minutes ago that Cassandra don't have joins, okay? And as you can see here, we do have many-to-many relationship between two entities. So pay attention. This is how we do modelization in those cases. Just that.
Yep. Every user can comment a video, and he or she can do it multiple times. Good. But every comment belongs to one video. One comment cannot belong to multiple videos. Yeah. So we have both many to many, many to one. Good. Then, speaking about this killer video or YouTube, easier to explain workflow. We have two main use cases. When we open a video page, when a user opens a video page, we have to show comments for this video. And we're thinking on the workflow one. Find comments related to the video using a video identifier. Get most recent comments first, implement paging. Because in some cases, well, you may have a lot of comments. And workflow two, find comments related to a user using user identifier. Most recent first, implement paging. To explain, workflow one is very simple. You open a video at YouTube, you see the comments. Okay, simple. Workflow two, it's a little bit different. It's used when you as a user open your own profile page and you see your comments. So you see those comments will answer, for example, or those comments will got good rating, bad rating, or anything. And the same workflow is for administrators. or moderators, like they suppose one person is writing spam or any kind of bad messages. They want to open user profile page to watch all the last comments and maybe block this user. So those are two typical use cases for us to cover. And well, third workflow is to implement create, read, update, delete operations, but I'm not about that right now. Then mapping those ideas together, like conceptual data model and query or workflow, we think first one, find comments for a video with a known video ID, because when you are open a video at YouTube, video ID is already known because you've seen a list of the videos. And when we start to think of a table, comments by video. And then second workflow, find comments posted by a user with known user ID, present first. And when we start to think of a comments by a user, and we go to the next logical data model, comments by user with user ID as a partition key, creation date and comment ID as clustering columns, and video ID and comment as the data columns. And second table, comments by video with video ID as a primary key, partition key, creation date and comment ID as the clustering columns, user ID and comment by as a data columns. Now please answer my question. We are talking already about two different tables. Why cannot we have one single table? Please answer at Discord or YouTube. Yes, I already have a correct answer. Query require partition key. Yes. Okay. Oh, so first of all, thank you for your attention and thank you for answering my questions. I really appreciate that. I see really a lot of people writing their answers. In general, different query requirement. And the correct answer is, when we fetch comments by a user, we know user ID, but we do not know video ID. As we fetching comments by user, we know user ID, and then we are able to retrieve them as a single partition stored by a user ID in a very simple query. Comments by video, we do not know user ID. And like, let's say, how many users have YouTube? Really a lot. You don't want to try to load comments by video, trying to get all the user's ID, trying to load by a user. When we load comments by video, we know video ID, and we use video ID as the main thing. So basically, it may be solved by using allow filtering. So allow filtering allows you to ignore requirement for the partition key, but it's a very, 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 very bad practice. And now take a look. There is a serious, very serious thing. Like condition integration, continuous deployment, you have some tests running on Jenkins or tests running on whatever, Circle CI, whatever system you are using, GitHub Actions, for example, Travis CI. People mostly are using tests, like continuous integration tests. More advanced teams having also code style checks and checking for different code style violations, best practices violations, and so on and so forth. If you as a team start to use Cassandra, assure you are checking for the presence of allow filtering in the code which goes to production. And if you find a person who is adding allow filtering to your real production code, which works with your real servers and real customers, catch this person and explain why allow filtering is a bad practice. When you are having more than 3 servers, you definitely do not want to allow filtering and full cluster scans because it may just destroy performance of your cluster. Again, when you run a query, you must always specify full partition key. In this case, user ID or video ID. That's why we are having 2 tables.
Okay.
Good. And there were a question by Sai Ganesh Vutukuri. Hope I pronounced it right. In case I have different queries when we need different tables, does that mean duplication of petabytes of data? So first of all, that does mean duplication and that does mean denormalization. Correct. Second, does that mean duplication of petabytes of data? No, because in this case, let's take a look at this model. We are having user ID, video ID, creation date, comment ID, comment by itself. Those all are strings. And how big are them? User ID, video ID, comment ID are universally unique IDs. They are like, how much is UUID? 16 characters, something like that? Bit more? Around 20 characters, something like that.
And you will only copy what you need. Only the column you for a request. You won't duplicate every single record. User details, video details would have much more column than just comment by video. So yes, there is duplication, but not petabytes of duplication.
Yeah, definitely. Most of the comments, well, I don't know how big can be comments at YouTube. Never tried to write too big, but I do bet they have some reasonable limitation. I don't know.
Let's try big for the video.
Yeah, we can do it. So duplication, yes. Denormalization, yes. Petabytes, no. What's really important here? Well, some people say, hey, denormalization is great. I do disagree. For me, as a former developer, denormalization is not great because it means now I have to do more work in order to have some integrity for data. But it's exactly the price to pay working with geographically distributed data with some big amounts of data still able to dispatch it and retrieve it within milliseconds. Sorry. Again, no unicorns. If you have a ticket to Unicorn Worlds, Cedric wanted one and I would join him.
Yes.
Okay, let's move on from logical data model. Oops, wrong page.
To physical data model.
Physical data model. And now comes some very nice optimization improvement from a Cassandra side. For example, take a look. Before we had creation date and comment ID as 2 single entities, as 2 different rows, and now boom, they are merged. How? Because Cassandra offers a really great column type called time UUID. It behaves like a UUID, universally unique ID, this long row of numbers and characters, but it has a timestamp integrated within. So you can sort it by time and extract time out of it. And that's a really great and convenient tool to store 2 things together. So we finally speak of 2 tables. Comments by user, user ID, comment ID, video ID, comment. Clustered, grouped by user ID, and comments by video, video ID, comment ID, user ID, comment, grouped by video ID. Good.
Yeah, we can see that those are exactly the same column, but not in the same order, and of course not the same primary key. And now this is the role of the application to each time they edit or remove a comment to update both tables.
Yep. As Charlie says in YouTube, yeah, a time UUID is actually really cool. I do agree that's really a great thing for many of the use cases. Good. So when we speak about the schema definitions, we are going to create table, if not exist, comments by user, user ID, type UUID, comment ID, time UUID, video ID, again, UUID, comment, text. Primary key will consist of user ID and comment ID, where user ID is a partition key and comment ID is a clustering column. And with clustering, order by comment ID descending. Let me explain why I think. First, about clustering. As I said before, clustering columns ensure sorting order. So, in this case, don't forget, comment ID is a time UUID. So it has timestamp integrated into the UUID. And comment ID is, in this case, used to sort descending, and that's a really cool thing. It's a part of our operations course at the academy.datastacks.com, and a part of our Cassandra Day, full day event we run sometimes. In this case, just to explain, data in Cassandra is sorted based on the clustering columns at the insert time in memory. And then you do request, select user ID, comment from comments by user. They are pre-sorted at the insert time. So no Cassandra cluster, no Cassandra node does sorting at the execution on the select statement. Data is pre-sorted. And that's what makes Cassandra delivering you already sorted data very, very quickly. And that's cool. Second point to explain, primary key consists of a partition key, which is user ID in this case, and comment ID is a clustering column. Take a look. We discussed why we have user ID as a partition key. Yes, because we partition our data by user. In this case, it's a table comments by user. And that's the second question. Why do we need comment ID in the primary key? Answer is to ensure uniqueness, because when you create a lot of comments, and we have user ID to group and comment ID to specify uniqueness, to ensure an uniqueness, and well, for sorting in this case. Second table looks very familiar. The idea is exactly the same, just in another order. We are having video ID as a primary key. But besides that, they are mostly the same. Again, yes, denormalization. How do we work with denormalization? Cedric will show you 2 steps later. And then, based on these tables, we work with queries. Select all from comments by user, given user ID. Select all from comments by video, given video ID. There is one, again, very good question on the YouTube. I want to voice up. Satya Murthy. So should we not think of Cassandra for analytics, where every day we get different asks to get data? Very good question and very typical question. So my answer is, what's really important is to use proper tool in some particular situations. Like if you need a hammer, don't use a screwdriver, and so on. So Cassandra by itself ensures very quick operations with very big amounts of data everywhere over the world. Cassandra is an OLTP database, so it works very quickly with big amounts of data. But again, there is a price to pay. So search and analytic capabilities are very, very poor, as you have seen. Now, obviously, question comes, I do not only store my data, but I sort my data, I search my data, I run analytics queries on my data. How do I handle this situation? Answer is teamwork. Best friend for Apache Cassandra is Apache Spark. Apache Spark is an incredible tool. It's one of the best tools for search and analytic capabilities. It has some machine learning enabled things. It has some SQL things. For example, having Apache Spark next to Apache Cassandra, you may run SQL queries to SQL data, and you may have joins, foreign keys, relation constraints running Apache Spark next to Apache Cassandra. And that's really great. You really may run SQL over SQL with all the things. The only limitation, again, will be the performance. Nearly any, so a Spark will do joins for you, and you will have joins, But again, every join in this case is a full cluster scan. So it not will be quick. But for analytic purposes, it's mostly fine. If you want to have very quick responses and search capabilities, and you still have requirements for performance to be very quick, for real customers to work, not with your analytic teams or machine learning departments, then you may need some more sophisticated solutions. Like, for example, Kafka. With Kafka, you can stream data to Cassandra and to any another search-enabled database, maybe not so quick, but search-enabled, Elasticsearch or whatever, Spark as well. And or you can have this database alongside with Cassandra or behind Cassandra and pull data with Kafka out from Cassandra to any more search and analytic OLAP, OLAP databases alongside with. So that's the teamwork about. Hope I've answered. So can we consider Spark as making Cassandra a true NoSQL database champion? Well, my answer is yes. My answer is yes, yes. Teamwork and those two tools work perfectly together. So, Cedric, it's your turn.
Yes, it is.
Give me a second. I will switch the screen to you. Yes, sir. You are live.
All right, then. So two things. We can start doing exercise number 4 and go back to the quiz mode. Okay? Let's see how it goes. So exercise 4, remember how we imported exercise 4? I just go there, put files number 4, drag and drop. If I do it again, I will have a duplication in my notebooks. It's not a big deal. Now I've imported it twice. Okay, so I open my notebook, as you do, and yet again, everything's written, so I can go to the first cell, execute the first cell just to create the table I need. And in the meantime, they ask me to look at one table in particular called video recommendation. So if I look at this video, wait for this, okay, first query is successful. Then I can see that primary key is user ID as partition key, even if there is no double bracket. Cassandra considers then that the first part of the primary key is partition key, and 2 IDs. Look at that. It's very look like the comment by video we saw before. Okay, and so based on that, it will ask me to select star from the table. Okay, I do have 3 records, and I want to get one of the records. So I will say, give me one record, and I provide the partition key. All right, it's not a unique record because partition key alone do not ensure unicity. It's the full partition key. Okay, and Cassandra is happy because I'm using the partition key in my workloads. But look at the rating. Now, if I try to execute the same query, but instead of providing user ID, I provide the rating. Rating is not part of the primary key, so bada boom, error Cassandra, I'm not happy with your queries. I need to do full scan of cluster. So this is a guardrails. Cassandra does not allow you to do it by default, but you can enforce by providing allow filtering. I don't believe that's actually showing that to you. If you need allow filtering in your query, your data model is wrong and it will be slow and it's your fault, not Cassandra's fault. So now that I'm doing that, okay, it's working because I told Cassandra, I know I'm stupid, I'm doing allow filtering. Yeah, it's a bit too much, but that's really like that. You know, Patrick McFadden used to say that it should have been called allow numbering. Duplication is the way to go, duplicate. Okay, and he's not happy. So, and this is exactly what has been described all along. And so this is the first item to check. Second item to check in this exercise is every insert is also upsert. If the record does not exist, we create the record. If the record already exists, we will update the values and do not do any error. No constraint, integrity constraint error. So let's see how it goes. I select. So first, I see that in my tables, I do have an existing record, 1111, with email gc@datasax.com. Okay. I will try to insert the value with exactly the same primary key, okay, user ID. And now instead I've just changing the timestamp. And I do have no error because every insert is an upsert if the result already exists. And so if again I want to select, you can see that my record has been updated. Okay, every insert is an upsert. By default, there is no read before write, and this is the reason why Cassandra is so fast. Okay, so we have been a bit chatty lately, so I will let you do the rest of the exercise as homework, and I will make a bit spicy here and propose you to move back to the quiz mode because we are already at the top of the hours. All right, so let me switch into quiz mode. Here it is. We do have the laser board ready to go. Theorem on top of things. And I will go to second part of the quiz, Cassandra data modeling. And I can see that the thumb up are running. It was a long talk, but yeah, it's time to play. Let's have a bit of fun.
Yeah. Don't forget menti.com code 640466 and press the thumbs up button.
Please.
As I did.
Yep. You can also press the thumb up button on YouTube, by the way.
Oh yeah, you should. Actually, I want to say it one more time. You see only me and Cedric at the screen, but actually there is a big team working behind this event. People are answering questions at Discord and YouTube. People are making the stream real. People preparing the workshop materials, exercises. There is a very big team behind this workshop.
Yeah, 153. Okay, let's go with that. I think
yes.
It's not moving anymore. So, oh, now it's moving. Yeah, I shift quite quickly from the exercise to the quiz. Yeah, because we're running out of time. But yeah, I really want to have fun. As I told you, the exercise are very self-explanatory. Just read, and you can totally do it in an autonomous way. And Astra database won't go anywhere. It's a free tier. It will stay there. Okay.
So let's move on.
Yes, let's move on. Boom. Okay, okay, let me go like that. 1, 2, 3. Okay. Now Menti is complaining again.
Okay.
There is nothing special about my leaderboard. It should have been. Okay. Let me refresh one thing. Okay. Yes, it's ready.
Good.
Boom. A key space is...
What is a key space? Is organized into rows and columns, contains tables and sets replication, is the base unit of access, is a place to store extra house keys. 2, 1. Go. Time is up.
Boom.
Yes.
Yes. Contains
Yes.
table and set replication. Good job.
Good job. And base unit of access is a partition. And note key space is not organized into rows and columns because it's a table is organized in rows and columns, not a key space. Key space is a container for tables and it defines replication.
And so leaderboard, we keep using the same leaderboard. No. All right. Boom. Michael Scott. Good job.
Okay.
Moving on.
In Cassandra tables, which are required? Data columns, clustering columns, partition keys. What is required in Cassandra tables? Time is up. Yes. Correct answer is partition keys are truly required. You may have no data columns, it's fine if you need that. You may have no clustering columns, it's also fine. What really must be defined is a partition key.
Yes. And okay, Michael's got yeah,
Boom.
Good response. Perovic is back.
Yeah.
Boom. Perovic
So
was very fast.
Yes, Perovic or Perovic, I don't know. Shreya Ganatra.
Yeah,
Let's go back again. Michael Scott on the 4th place now. Hey guys, keep fighting,
okay,
guys
so
and girls.
Michael, yeah, last question. Be quick.
In Cassandra, tables hold. What tables hold? Many partitions, rows and columns, replication factors, an endless sea of hopes and dreams.
The last one is just gold.
Oh yeah. Table is a container for partitions. Oh my god, so many wrong answers.
Yeah, but at the same time, rows and columns are so legit.
Yeah, but that was a trap. Rows and columns are organizing data, but really is a table is a container for partitions. Yes, a replication factor is defined on a key space level. Replication factor does not belong to table. But we may want to add some more about the key space table partition way to explain it better in the next workshop.
Yes. Anyway, leaderboard for part 2 is yeah, of course. Yeah, that was quite expected. Yeah. But still, Abdulaziz made it and now has been, boom, promoted as a 2nd place.
Good. Perovic, Abdulaziz, Shreya Ganatra. Well, goes good. And she shares 3rd place with the same number of correct points with Lech Giovak.
Okay, thank you. So it's the 3 hours mark. So I propose you to go quickly with some slides about advanced data modeling and batches, no less than 15 minutes.
Yep.
And do the 2 remaining questions and survey. Okay, what do you think, Alex?
Yeah,
will do. Yeah, I think we need to make it quick just to steal everybody's time. But at the same time, it's very important also. Main concept is in the advanced data type and lightweight transaction. Okay.
Yes, because it's going to be very simple. So can you do advanced data types and I will do lightweight transactions maybe?
Right, let's do it.
Or I can do it here as you wish.
No, that's fine. Let's do advanced data type. Okay, so in a Cassandra table, you can have not only scalar type, integer, numbers, but also collections. 3 types of collection: set, list, and map. If you're a Java programmer or object-oriented programmer, those concepts should be very familiar to you. So how does it work? So first, set is a collection where you cannot have multiple times the same value. Set will remove all the duplicates. But at the same time, set don't keep the insertion order. Okay, 2 things to understand. Remove duplicate, but order is not maintained. And so how does it work? You can insert into a set using some curl bracket like that. You can replace the entire set with update set, and you can add or remove items from a set using update set tags plus tags or tags minus. Okay, and I'm using curl bracket. Okay, list. In a list, duplication are not removed. Okay, we insert everything, nothing is removed, and now the order is conserved. Okay, conserve the inserting order. Okay, so now it's quite the same syntax, but except of using curl bracket, we are using square bracket. So insert, replace the entire value, and append item from the list. Because lists are indexed, now the order is there and will stay there. We can access one value in the list using the indexed notation. Actors bracket 1, I will fetch the second item of my list, because yes, we start at 0 like every programming language. But pay attention. Now Cassandra need to figure that second item really exists in the list. So there is a read before actually the real update. So this request will be twice slower than just not providing the indexed notation like that. Okay. Last but not least, we do have map. So map key value, not the map like the pictures on the right part of the screen. Really like Java. So you can insert using key value using curl brackets and quote, because it's a map of text. So both keys and value are text. So using quote, insert, update, add to map. So with the plus notation, same as a set. Okay. You can use collection, but you can also use user-defined type. Remember, we told you there is no joins in Cassandra. So one way to implement one-to-many joins would be to define a dedicated object like address. I provide attributes, street, city, and state, and I can use this new object address as a type for a column, for instance here, of the table users. So now in the users, I do have something called location of type address. And you can play with all that. You can have a list of address, a set of address, a map of text address. You can have nested unity, and you can start playing like JSON-ish kind of format, but you don't want really to store JSON in Cassandra like that. There is a schema here, so you must stick to the schema. And this is how it looks like. So I can insert updates or update one value yet again. But now the keys do not have quote, because keys are real attributes of the UDT object. So street, city, state. And I can insert only a city. And I can also select only one portion, one subtype of my UDT like that, like a select. I can totally go select location.city. Okay, last but not least for this advanced data type is all about counters. you can define some counters, but those do not work at all the same as Oracle sequence. It's a distributed counter. So if it's distributed and you want to avoid distributed locks, it's quite imprecise. It will be consistent quite soon using the same Cassandra mechanism, asynchronous replication, but don't expect counters to count something with immediate consistency real time. So to do it, it's really meant to store imprecise values such as like or views, and with that you can increment, decrement. You can never insert. If you define a counter, every column of the table must be a counter, and counters cannot be part of the primary key. Okay, so this is a sample with the video playback stats. Video ID is my primary key, also partition key. It's not a counters. Views is counters, and any other column I would put in this table would be counters. Okay, how to work with those? Remember, we provide you all the slides as a PDF in GitHub repo. So to increment, I will update set views equals views plus, and decrement views equal views minus. If it does not exist, it will create the record, but there is no insert statement when it comes to counters. So exercise 5 is all about advanced data type, but I will let you this one as a homework as well, and I will let Alex do the remaining notion, which are lightweight transaction and batches.
Yep. So I am live, and I will say some words about lightweight transactions and batches, and that's basically the very close to end of this workshop. Last two topics, but very important topics. So, lightweight transactions, what is it and how it works? First, very important to understand, Cassandra lightweight transactions are not the transactions you are used to use in the relational databases. There is no commit, no rollback. Once more, no commit, no rollback. Those are different kind of transactions. Yes. Sometimes insert or update operations must be unique. And you don't want to repeat operation if these, for example, primary key already exist. And it requires read before write. By default, Cassandra does not do read before write, but it may happen if you explicitly ask for it. Good side, Cassandra will do read before write. Bad side, you obviously are going to pay for it by the time. So read before write takes some time to execute. Don't forget, data is distributed over multiple servers over different availability zones. Cassandra Query Language lightweight transactions solve the problem of read before write doing read before write. It happens when you use an if clause and inserts and updates. What's the most typical use case for this thing? Problem. Imagine we have two instances of our application working with the same database. Very often use case. Application instance A loads some data, and application instance B loads the same data. Then application instance A makes changes to record, and application instance B also does the changes. And then problem comes, application instance A loses all its records. There are my changes. What happened here? Example for this one. We are reading, let's take a look. We have an empty killer video user credentials, and we are trying to read credentials for a user with email newuser@gmail.com. We have no rows. This user does not exist. This email is not registered yet. So we are running a query, insert into killer video user credentials, email, password, user ID, values, blah, 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 adding lightweight transaction if not exist. And this insert will be executed. And in the metadata of the answer of the response, it will have property applied equals true because this insert has been successfully applied. And when we try to read this data, we select from killer video, blah, 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 with this email, newuser@gmail.com, and we are having this row, as expected. So this table has a row new user gmail.com with password A. Now, let's say someone tries to register using the same email. Usually, Cassandra by default uses upsert. So having the same primary key will lead to the overwriting of the existing row. So it will be a new user, but with a password not A, but XYZ, as specified in this insert. But we have a lightweight transaction, if not exists. And password is different. And the returned answer will be success, because, well, lightweight transaction doesn't lead to a failure. It's successfully executed operation. But value of the property applied will be false, because applied is, well, it was not being applied. Password field didn't change. Then we are trying to read from this table for this user, and we see what password was not changed. Good. So lightweight transactions support very interesting things. So you may have not only if not exist, but also if if money equals 500. For example, your application to different instances using with a customer trying to buy something, and a customer tries to buy two different things, but on his account he has enough money only for one thing. Therefore, it's very important here to have to consider lightweight transactions. So you will not execute a purchase operation then customer doesn't have already enough money. You have to check what I'm trying to purchase something, and I'm trying to decrease amount of money at the person's account if this account statement has not changed. And then you say, like, we try to load data record 1, and we try to write record 1A and write record 1B if the previous value has not changed. And if previous value stored in the application instance has changed, then we have to react to something and try to load again this value and check if operation can be executed.
Yes, Alex. So you already explained how it works. So now Cassandra needs to do a read before the write, because it needs to execute the condition. So first, the condition is only valid for a specific partition. So it's limited in space of data you are working with. And also now it's 4 times slower than a regular insert, because I need to, it's all the Paxos stuff. I need first to check that the resources are ready to go. I do a first call to check the condition. Then I'm doing the editing and pre-commit, and I'm doing kind of commit in the end just to be sure. So it's 4 rounds between you and between the customers and Cassandra to execute a lightweight transaction. So it's very convenient, but when you use it, pay attention about performance.
Yep, thank you, Cedric. That's important. Good. Then next being batches. Batches is a great tool. We use batches due to denormalization thing. Remember, with denormalization, we store our data into multiple tables, and when we can retrieve this data in a single query, very quick, no joins, simple, easy, and within milliseconds. But then we change something or insert something. We have to put the same value into the multiple tables. And what we use for that is a batch. Batch we use when we need to mutate a record or insert a new record in multiple tables. And SQL batch, again, is not the same as SQL batch. I repeat this phrase, SQL is not as SQL, 5 times already today, I believe. Okay, so imagine you have a list of inserts, like 3 inserts. We have to insert a new comment into video, comments by video, comments by user, comments by something. And one of those inserts may fail. And when we have a situation of failure integrity, as we have comment in 2 tables, but not in the 3 tables. And with batch, we can ensure what operation has been executed for all the insert or update statements we are having within the batch. Now, the most asked question about the batch, if batch atomic. So can we ensure what all the changes were executed at the very same moment of time? So, or no inserts was not executed, or if no insert was executed, or all inserts were executed already. Answer is batch is not atomic. So in theory, you may run into the situation when first two inserts were executed already and third one were not executed already. That's a rare case, but technically it's possible. Why use batch? Batch has a very strong retry and persistence mechanism to make sure all operation complete. If operation fails, first batch will retry your write operations, and if it by any occasion not possible anymore, then application will be informed what batch has failed. Basically, batch first goes to a closest coordinator node, being persisted there as a real file, so even if a coordinator node will fail by power or by anything, this persisted batch will be replayed, and after that, batch status will be changed to successful, and you can retrieve this information. So, I guess we do not have time for lightweight transactions and batches exercise, do we? Or do you want to do it?
No, I think we don't have time for the exercise. So I would propose to go quickly. You go quickly to the resources we share.
Okay.
And then I share my screen and we do both the last quiz and the survey, and we are done.
Great. So resources, we have prepared some important things for you to do. What to do next? Learn. We have academy.datastacks.com. There is a huge set of courses, big and small, to learn Cassandra and Cassandra-related technologies, like how Cassandra integrates with Spark, and so on and so forth. It's free, and that's great. To ask questions, as there were so many people today, we were not able to answer all the questions. Then, if you still have questions, which definitely may happen, go to the community.datastacks.com. It's like a Stack Overflow, but dedicated for Cassandra and DataStax Enterprise. Share your expertise, answer questions, and ask questions as well. Connect with us via at YouTube, Twitter, Twitch as DataStax Devs, and this YouTube channel is the main online stream for us, so please subscribe. And slides, notebooks, exercises, code for this course is available at github.com at DataStax Academy online Cassandra workshop. Your Astra database at a free tier stays yours forever, so please feel free to use it for these or next workshops. One very good thing with all those ages of the disturbance and pandemic and so on and so forth, we offer site reliability engineers for Apache Cassandra, open source Apache Cassandra, for Cassandra cluster health checks and some diagnostics and our discussions and work with site reliability engineers of DataStax at no charge, completely for free. If you're already using Cassandra and you're having some issues, or maybe you plan to migrating, you may write an email to keepcalm@datastacks.com and discuss with our team what's going on and how we can help. Training courses at DataStax Academy. For every exam, we do recommend you to take free courses. So DataStax Enterprise Foundations of Apache Cassandra, well, that's in general essentials of Apache Cassandra. Operations, if you are an administrator. Application data modeling, it's a full course. What we did a brief overview. Today it was a brief overview of a full data modeling course we do here.
Yes.
Graph, for those who are interested in graph databases, and graph analytics, which is a new one. But well, that's already about DataStax Enterprise. As a reference application, we use very often Killer Video, Killer Video is a free reference application. You may see how we work with Apache Cassandra. And upcoming events tomorrow, for everyone who is interested into the distributed testing of distributed applications, tomorrow we have a tool which is now open sourced, how DataStax tests Apache Cassandra and DataStax Enterprise. It's now available for everyone as an open source project. It's called a DataStax Fallout. And we ask you to join us at this workshop tomorrow. This Friday, we are having a big event, Cassandra Day Russia, for everyone Russian speaking. I suggest you to join us at Cassandra Day Russia, where will be full day, free big workshops getting into the details of how Cassandra works, and some talks of the experts about some integrations and more advanced stuff for those who already have experience. And when we have, again, Cassandra Developer Workshop, repeated like this one, NoSQL benchmark for data models for NoSQL, not only Cassandra, but other tools, and some more things like Apache Cassandra and Kafka, Apache Cassandra and Kubernetes, and many other things. Stay tuned. And then, yes, Cedric, it's your turn.
Yes, as you can see, we do have a lot of events coming. These are only the 3 next weeks. So if you want to register to those events, you can either subscribe to the channel to get a notification, or go to Eventbrite/DataStax to know what's coming. And with that, you will give me back
already
the screen sharing. Okay, so let me go to quiz mode.
Let's go with a quiz.
Okay, so 2 last questions and we got the final leaderboard. I don't think they still share. Okay, now it's coming. They were literally on YouTube. Okay, so let's get starting. Question 1. I will wait a bit. It's still moving. Okay, yeah, I don't want you to miss the last 2 questions of the day. I mean, for the quiz. After that, we do have a survey just to improve, give a chance for you to give us your feedback and what we can do better, if we should do more of these events, and what are the content you would like us to cover. You would have all the way to do it in Menti right after this quiz. Okay, let's get starting. And I will, yet again, start the quiz. Okay, Jai. Man, I really need those 2 questions. It's okay. I really need those questions to be there. Okay. He asked me to reload the page. Okay, let's reload the page. Maybe it was not so quick. Okay, let's do it again. Start. Boom. How does Cassandra perform joins?
Cassandra joins require a join table. Just like SQL joins, Cassandra does not support joins. Now I'm really curious.
Okay.
And the correct answer is Cassandra does not support joins. And notice, Cassandra joins require a join table. There is no thing like a join table in Cassandra.
Yes. Leaderboard. Okay, and final question. Perovich. Okay. Oh, you will You will cross the 10,000 points mark.
It looks like.
Here we go. Last question.
One. In Cassandra data modeling, what do you do in Cassandra data modeling? Model your data with normal forms. Start by creating fact tables. Start with your application workflows. Always walk on the right side of the catwalk. Okay.
Number 4.
Sure.
Yes.
Yes.
Yeah, we mean it.
Yeah. In Cassandra data modeling, you start with your application workflows. Think how your users will use your application. Think of your queries. And answer model your data with normal forms is wrong. Sorry. We don't use normal forms. We go with denormalization.
Okay, and boom! Congratulations, Perovic. Congratulations. Yep.
10,000 points. That's a very good result. Very good result.
Yes, but yet again, the three first will get the swag. So reach out to Jack.
Stop, but wait a second. Okay, Shreya Ganatra is new, but Lech Giovak got the place already, I believe.
Okay, so if that's the case, let's ask Barisk, and that would be everybody above 10,000 points get the swag.
Good.
Nice.
Yeah.
All right. Okay, so again, thank you very much. Only remaining thing we have to you is a quick survey still on Menti. So 6 questions. We would love your feedback. It would be pretty fast and it helps us to improve. Don't worry. Don't forget to subscribe to the YouTube channel if you like it to get notified. Okay. How likely is it that you would recommend this event to a friend or colleague? Wow.
Oh,
wow.
Nice.
That's nice. Okay, today was really all about getting started with Cassandra with a little bit of advanced things for data modeling. But hey, soon we will do, application developments, Kubernetes, machine learning, Kafka. We have plenty of workshops ready to go. Those are already, some are already pre-registered on the YouTube channel. Working the same. You don't have to install anything. We provide you what you need to do the exercise. Okay, question number 2. It's not moving anymore. How long should those workshops last? So today it was 3 hours, and for sometimes we do 2 hours. Seems like it's a sweet spot. So in the incoming event, including for EMEA, maybe we would stick to 2 hours. Today, 2 hours each day with exercise in between. Things like 3 hours is relevant for you as well. Not bad. So 3 hours is not bad. It's 3 hours and 30 minutes already. So and you are still with us. So that also means that you guys are awesome. All right, 120. I do have my quota. 3 over 6. How easy was it to get help during the workshop? So meaning answering your question on Discord and YouTube. So for those who are asking why we are not only using YouTube, so the chat can scroll very fast and we can miss some question. And Discord is really neat for that. We keep all the question, all answer for all the workshop, and we can provide dedicated answer for dedicated people. And if they run into trouble, we do have breakout rooms to troubleshoot them, even including screen sharing and everything like that.
For everyone who is not fully satisfied with the help during the workshop, we are very sorry, but altogether we had more than 500 attendees, counting YouTube and Twitch, and we were not able to answer every question. But to smooth that, we have community.datastacks.com, so go there and ask your questions, and we will answer them there.
Yes, this is Stack Overflow for Cassandra. Get there, get all your questions about Cassandra out, how to get started, And we do provide multiple language, by the way. So we do have the French, English, of course, but also extra language, including Portuguese, I think.
Russian, Chinese, Spanish. I don't remember, to be honest.
So. Yeah. So we have plenty of language for EMEA folks as well.
Yeah.
How easy was it to attend? So this name is, split brain, Discord, YouTube. We try to be consistent, but hey, the replication factor is 2.
Well,
okay, that's good score.
Yeah, it's a good score. YouTube, please, plus Twitch, plus Discord, yeah.
So we have planned also to stream on LinkedIn for people blocked on their business laptop for YouTube. It's coming. We try. Learning by doing. Okay, 2 remaining questions. 120, almost there. Thank you for being with us until now. How do you hear about this event? What can we do to promote the event? Is it direct email? Sometimes newsletter and direct emailing is not the best. So, okay, Eventbrite, direct emailing. Okay. Still fair. We will probably include maybe an introduction video in the direct email just to make things more appealing. I think we do have a lot of interactivity during those events, and we should make that obvious even in the email.
But yeah, that's interesting to see. Great.
Still Eventbrite, yeah, Eventbrite is the way to go. This is where we are sharing all the incoming dates. And the reason is you don't have to provide any information, still anonymous. Go there, community driven, and let the share spread, let the knowledge spread. Okay, and last is up to you. It's a free question. And so presenter 2. Okay, boom, it's working. I like how it works,
Yeah. Thank you.
Oh, nice. Great session, great effort. Yeah, nice.
So it looks like we did a good job for everyone on the screen and all the big team behind the screen. It was a good.
Oh yeah, for the break, look at that. We had a 3-minute break and we are so much late already. So yes, maybe next time we will remove stuff or do 2 parts. Why not?
Yeah, maybe. But in general, I like this format. Yeah, okay, that's 3 hours and something. Maybe I was too talkative, but still, well, you know what? When you start to speak about the complex technologies like this one, whatever you are trying to skip is like you think, okay, I should not skip this step because it's very important, and that is very important, and this and very important, and in the end, boom, it's an end of a day.
I saw some comment for Apache. So Apache is coming. Next session will be in 2 weeks about Kubernetes. We will run Cassandra in a Kubernetes cluster all together. Excellent session. Nice. I can keep watching this feedback all day long. But okay, again, thank you very much for your time. Hope you like it. We share all the content with you. It's all available on GitHub. And subscribe for next session. Why not tomorrow, for instance? Thank you very much, and bye.
Thank you. See you then on our next workshops. And thank you for being with us. Ciao.
Ciao.